Hello everyone, good afternoon. Hope you guys are doing fine. So I request all my dear professors, students, colleagues to join in fast so we can start in couple of minutes. So guys, today is last day. So today is going to be very exciting. So we'll try to understand the entire recurrent neural network and we'll try to make a project around it. So I request everyone to join in fast so we can finish in time by 5, and then obviously we'll have a question and answer session. And prior to that, guys, we'll try to implement today convolution neural network code walkthrough. So we'll try to understand the project for the COVID detection using convolution neural network and using the computer vision. So hope I will sharing the agenda in couple of minutes, guys. Hope everyone finds it very exciting, and I request all of you to tell your friends, colleagues to join in fast so we can start the session at earliest. Hi guys, good afternoon everyone. So hope you guys I've joined. Whosoever not joined in, guys, I request everyone to join in fast, so we can start the session at the earliest. Today we have to cover the lot of exciting topics. So especially from the NLP side as well, we need to understand the recurrent neural network. We have to implement one project using the recurrent neural network, guys. And from the computer vision side, we want to implement the project for the computer vision, a small project, then one supervised project using the transfer learning, and then one more project from the medical imaging side. Or possible, we'll try to cover one YOLO project, how to perform object detection, guys. So I request everyone to join in fast, guys. I'm going to start session in 2 minutes. So we don't want to waste the time. A lot of interesting topic to be discussed, and hope you guys will also find it very interesting. So who's not joined in, guys, please tell your friends, colleagues, and dear professors, please tell everyone to join in fast. So we can start. We are supposed to reach around 300, 400 plus. Still only 150 around people have joined in. Okay. So let me discuss the agenda, guys. Meanwhile, before other people joins in. So guys, first, what we'll try to do is today, we are actually planning, we were planning that we'll be able to cover the entire YOLO model architecture as well, but due to the limitation and a lot of intense discussion we had around this entire convolution neural network. So we'll not go into the architecture, but we'll try to understand how to perform object detection using YOLO. We'll try to understand this YOLO model. So we'll try to implement this YOLO model, and I will try to tell you like how to customize this YOLO model for your own object detection class. This is the one topic we'll be taking. So this way I will keep it at priority 2. Priority 1, guys, I'll try to show you how to build our own CNN model. How to build, right? How to build our own CNN model, own architecture, own CNN model. And then, guys, we'll try to understand one more project, which will be using the transfer learning. Transfer learning project, COVID detection. From the chest X-ray, we'll try to understand COVID-19 detection. Okay, COVID-19 detection using chest X-ray. So this is what we'll try to cover from the computer vision task, guys. I hope everyone is now clear how to build our own convolution neural network, and then YOLO model, and then the transfer learning model, using which we'll try to understand the COVID-19. So let me write it in proper way. So this gonna be priority one. Priority one gonna be this way. So we'll not cover this YOLO architecture. We'll directly cover the creating the CNN, creating the CNN model, CNN. Okay. Then we'll try to implement YOLO NAS model, guys, which is one of the latest model. And the third thing which we'll try to understand, we'll try to understand the customization as well. And the fourth part, which is like a COVID detection, COVID-19 detection project. We'll try to take a look at it. Okay. And then, guys, we want to discuss the main topic, second half. We want to discuss around the introduction to RNN, recurrent neural network, and we'll try to implement one project using RNN. Project using RNN, so maybe a fake news detection or something like that. Project using RNN. So for the NLP domain, this is what we'll try to cover, because we have covered already the basics. If you want, you let me know, guys, if you also require some kind of a brush up or kind of a quick review around the RNN. So I will try to cover the not RNN, actually the basic NLP, like how we perform tokenization, and then we perform streaming, data cleansing, data pre-processing. If you want, I will quickly, like 5 to 10 minutes, I'll try to take a recap, and then we'll start the RNN, guys. So first 1 hour I'll try to dedicate for code implementation for computer vision, and second 1 hour I'll try to keep it here. So I think we are already late, guys. We can start. I think it's already 3:15. So I encourage all the participants to join in fast, so we can you guys will not miss any project. All right. So guys, give me a confirmation if we could go ahead and start the topic for the day. Whosoever joined in, give me confirmation that you guys are able to see my screen entirely and you can hear me properly, so we can start. Yeah, okay. Thank you, Kamesh. Thanks for confirmation. So guys, let me stop sharing my screen and let me share my entire screen with you guys. So first thing, we're going to start with the convolution neural network, how to build our own convolution neural network architecture. And for that reason, I'll be sharing with you this code. Okay. So I don't want to share my particular window. I'm going to share my entire screen only. So you guys can see the entire screen. Right, guys. So just give me one moment. Let me start. All right, guys. So we'll try to build one kind of a classifier out here. So guys, before I start, just give me one more confirmation that you guys can see my entire screen. You guys can see my entire screen. Please let me know, guys, in chat box from the participant side, and then we can start. So there will be no further disturbances. Okay, Datta, thank you. So guys, what we going to do is we're going to build one kind of a classifier here. So we'll try to perform one binary class classification out here. So let me tell you guys. Okay. So we are going to build one binary classifier. Okay. Binary classifier. This binary classifier, guys, what we try to do is we'll try to build one binary classifier in such a way that we'll try to use the convolution neural network and we'll try to create our own architecture. It is not the copy of anyone else. Our own architecture we're going to create. All right. And within 5 to 10 line of a code, guys, within the 5 to 10 line of code, we'll try to build this binary classifier, which will be able to classify the images. Okay. Which will be able to classify the images into two categories. So we'll try to, for that purpose, we'll try to take a simple dogcat classification project and we'll try to understand how one can build this kind of a classification project using a convolution neural network, right? So we have seen on entire convolution neural network, how it's worked upon, what is a convolution block, what kind of operation happens, and what is convolution operation, what is pooling operation, what is padding operation, how the entire phase get detected in the convolution neural network operation, and end of it, how it is able to learn entire things and feature extraction happens, right? So this is what we have seen. So guys, for that purpose, what I'm going to do, let me rub these things and let me show you the data set which I'm trying to take. And for that reason, and let me show you the entire data set. Okay. So guys, this is the data set I'm using from the Kaggle. And if you try to look at the data set, guys, so this is the train data and test data. Let me show you the train data. For the train data, I created two folders, guys. One is for cat, one is for dog. And for each category, I have taken 10,000 picture each. If you try to click on this picture, guys, you will be able to see the entire dog images, colored images with different breeds, different category, different kind of a breeds and different kind of a lighting condition with different kind of a pictures and with all the possibilities, right? Like this way, we have taken a 10,000 images for the dog. And similarly, guys, I have taken a 10,000 images for the cat category, okay, for the class cat. And we will be able to see all kind of a cats are possible behind the bars, inside the bar, within the house, outside, in open condition, all lighting condition, all possible picture, all possible angles, and all different breeds of the cats we have taken, right? This is what we have taken, guys, and this is 10,000 each for each category. And then in the test, guys, again what I've done is for cat, I have taken 2,500 images, different 2,500 images, and 2,500 different images for the dog category. Again, these images will be different from the training, and again we try to take all possible breeds and all possible lighting condition, all possible angles as well, if you see. All right, guys. So this is what the data I've taken. You can find this data set link out here in the Kaggle data set. All right. So what we're going to do is, now we're going to build a classifier and we'll try to understand within the few line of a code how we can create a simple classifier. Then we'll try to understand how to build a complex architecture around it, or how can we use the already built architecture and customize it, right? So guys, first thing what I'm going to do is, this is the link I have shared here. Dataset link, http kaggle.com dataset salgar and docs and cat. Okay. So what I'm going to do is I'm going to create one folder out here by using mkdir kaggle, and within that kaggle, guys, I'm going to create one. I'm going to change the folder to kaggle, and within that I'm going to download this entire link of the data. And once I download, I will be able to get a zip file, and that zip file I will try to unzip it so that I will have a both the entire data set, 20,000 images for the training and 5,000 images for the test data set. That's what I'm going to do. First, I'm going to run this command mkdir then /p kaggle, and when I'm cp changing my directory to kaggle. Okay. Okay. It's loading back again. Okay. So wait for 1 minute and then we can continue our discussion. Okay, guys. So this is what the directory has been created. Then what we try to do is, now I am creating this command percentage sign explanatory sign kaggle dataset download. Okay, this is my command kaggle dataset download, and I'm providing this folder, guys, Selenium, docs and cats. And the moment I run this, guys, you will be able to already run it. So I'm not going to run it again. So what I am trying to do is I am trying to download this folder zip file, guys. Yes, guys. Sanam, it's necessary that you create a separate folder for training and testing, because we have to provide the similar path, right? We have to provide the similar path. So from that path only, it will be able to understand the category of the data. And what you are saying, testing data, and be done in similar ways as we did last time. One folder for cat and for dog, and then split. No. Will not. It is not advisable, because what is going to happen is, within that it was a inborn data set, like a digit data set which you are talking about, and then we splitted it, right? It was inbuilt data set actually, so that's why it was possible. So it was the convenient one. So that's why and this data set, actually this is different data set, and the data is also very huge. You can see 25,000 plus images we are trying to take here. So that is why it is always advisable that we create a different folders. Okay. And then from creating different folder, we can directly pass the path for the images, right? So guys, what I'm trying to do is I'm going to download those zip files. You can see here, the moment I said data set download dog and cat, and the two zip file will be created. Then I'm going to unzip it using zip file.zip file, and then passing this entire zip file path, and then saying extract all in this content folder, this folder content folder, and then I'm closing that zip ref. Okay. And then once I content that, guys, my job is done. Entire data set will be downloaded over here, right? Then, guys, what I'm trying to do is I'm going to import my libraries. Now try to understand, just like the data set, just like the similar way created the entire data frame, entire packages using the TensorFlow and the Keras, we are going to perform the same thing, guys. Okay, just guys, give me 1 moment. Yeah, sorry for the disturbance, guys. Sorry for that. So, guys, let's try to understand what we're going to do is, now what I'm going to do is I'm going to build my convolution neural network from the scratch, actually. It is not the architecture which I am going to download from someone else. It is directly from the scratch I am downloading this model. So what I am going to do is I'm going to use the same library, TensorFlow and Keras, guys. And by using TensorFlow and Keras, I'm going to use and create this kind of a convolution neural network. And then from the convolution neural network, we'll try to build our classifier, guys. And for that reason, also in the background, I am using TensorFlow, and the high level API I am using, guys, Keras. All right. So both the things I am using, and by using that, we'll try to create our own architecture, and we'll try to build a CNN from the scratch, guys. So let's try to understand what we have to do. I am importing the same library, TensorFlow, and from TensorFlow, I am importing Keras, guys. And from Keras, you guys already know the same model will be there. Like I told you in the NN only artificial neural network, when we try to build it first time, I told you that the model gonna be same sequential. Okay, this is the same model, sequential model. Now only change will happen, guys, in the layering part, because the layers are different here. And you guys already know that CNN, convolution neural network, is a combination of the convolution block and plus the artificial neural network, right? So we going to add some additional layer out here. So add some additional layers out here, and then we try to perform this entire operation, right? So that's the reason. Along with the dense layer, guys, which is required to build the artificial neural network, we are going to call something called as convolution 2D. So this is for the convolution block. Then another operation which we have, max pooling. We are trying to create a pooling operation. Then flattening operation. For that reason also, I'm calling that layer flattening. Then I'm calling one more layer, guys, batch normalization dropout. So if you remember, guys, batch normalization dropout, this we spoke about in ANN about the regularization techniques. So when you are facing a kind of overfitting or where your models are not doing good, at that time you can perform a dropout regulation, or you can also normalize. Batch normalization means whatever this kind of features you guys will be able to generate out of the convolution neural network from the image, you will be able to extract the features, and all those feature will be getting normalized, guys, once again, so that we can perform a prediction in a better manner. So for that purpose, we are performing the batch normalization and dropout. All right. So let's try to understand dense layer, then convolution layer, then max pooling, guys, then flatten layer, and batch normalization and dropout. These layers I am calling from the Keras dot layers. All right. So from Keras dot layers, I am calling this function, guys, and then from this function, we'll try to understand the entire layers. So how we can build these layers one by one. All right. So before I build this layer, guys, what I'm going to do, I'm going to create one kind of a generator now. So generator is nothing but simple. What I'm trying to do is I'm trying to create one kind of a variable and the path I'm going to create, because whatever the zip files I have downloaded here and stored it in the respective folders, that respective path I will be creating and I will be providing to my convolution neural network. So from where it will be able to take the training data, from where it will be able to take the testing data. Okay, that kind of a variable I'm going to create, and that variable will be called as generators now. So what is generator now? They are nothing but the same thing that we are trying to provide the path for our training and test data. So from where the entire my model will be able to take the data, and that's the reason, guys. All right. So I'm creating first generator as train ds, mean train data set. So keras dot utilities dot image data from directory. This is the function we are using. Image data from directory. This is a keras utility function. All right. So image data from directory, and then, guys, I will be passing over here. I'll be passing over here my path. Okay, this respective folder where I stored my zip files, right, which I downloaded from the Kaggle. So that path I am saving here, guys. I have created one folder here, Kaggle, and within that we created, you guys, I have shown you. So there are train folder, test folder, and within that there is a dog folder and there is a cat folder, right, for respective train and respective test. So same thing I am going to create here. I'm going to pass that path to my image from image data from image data set from directory. This function, which is a utility function from the Keras, right? So for this function, I'm going to pass the path, guys. You can see a directory equal to content. This is the content directory, and within that train folder is there. And also I have to pass, guys, labels, because so whatever labels, whatever the target is there, the target will be either it will be a cat or it will be a dog, right? So that label I have to also provide. So for that reason, I'm saying label equal to inferred means whatever the images I'm going to create, right? So if you remember whatever images we have created, let me rub this thing and show it to you again. So whatever these images are there, okay. So these images, if I try to go to the images, guys, you can see here, it is completely labeled images. You can say dog, then 1002.jpg. Means for the dog images, I have labeled it dog, and for the cat images, guys, we have labeled it cat, and but there is a different numbers given for the entire images, right? So whatever images are the, let's imagine this is a image number 10, so I have taken 10. So this is image number 10,000, I have taken cat 10,000. Okay. So this way, guys, already labeled the images. So that's from where it should be able to understand that which image belongs to which data set. That's the reason we are trying to pass that entire thing label equal to inferred, right? And then I'm passing my directory, guys, and label mode equal to integer, and then I'm passing my batch size. So whatever this 10,000 images I'm going to create, all right. So all that 10,000 images, how you should be able to take that images in watch kind of a batches to train that model, right? So that is the batch size I'm writing, and then this is my image size 256 by 256. That means 256 rows into 256 columns. 256 by 256 kind of a matrix will be created, and again it is a 3 channels. So it is a 3 comma 256 comma 256. So there will be 3 matrices created of 256 into 256, guys. All right. So this is what I am trying to pass, and this way I created the train. Same way I'm creating test, guys. All right. So test also the same, everything is same, guys, apart from the only directory name test. Here it is train. All right. So this is what is called as now generators. This generator will pass one train data set, entire test data set along with the labels and the batch sizes. So this is what the variable I have created. Then let's try to understand what is the next thing we'll be doing. Then guys, we'll try to come back here and try to normalize the data set, because whatever the data, just simple one function I've created, my user defined function is there, def equal to process. So I will accept the image and the label data, which is generated using this generator. And I'm going to, when it is converted into the tensors, right? So what is this tensor, guys? Tensor is nothing but an n-dimensional array. So whatever n-dimensional array, whatever image I am going to convert that image into the matrices, that matrices, every number will be divided by 255, because 255 is my maximum value. So that is why I'm going to divide by 255. And this way, guys, I'm trying to normalize my data, right? So once I normalize data, that's it. My data is ready, guys. My images, my entire packages are ready. My framework is ready, right? So now I'm trying to build my model now. So let's try to understand what kind of a model we're going to build here, guys. So let me show you to what kind of a model we are going to build here and what kind of architecture we are going to create here, guys. Okay. So guys, let me show you the architecture. I am going to create my first convolution block here. This conv block I will be creating, convolution block. And within that convolution block also, guys, I am going to create something called as three kind of a convolution layer, okay? And then I will be creating here my flattening layer. This one will be my flattening layer. I'll create a flatten. I'm going to write as a flatten. And then, guys, I will create my artificial neural network, okay? So this is the three things I am going to create: artificial neural network, two hidden layers, okay? So there will be two hidden layers, and one kind of output layer will be created. And then there is a flattening layer, right? So you can see here dense, then the dense, and then the one more dense, okay? So this kind of architecture, this is my input, this is my hidden layer, guys, and this is my output layer, which I am going to create. In the output, I am taken only one neuron, single neuron. This is what I am going to do. Let me rub the things and write it properly here. So this is my flattening layer will be there. And from the flattening layer, I am going to create this kind of a input layer first, IP layer, and then the hidden layer, guys, here, hidden layer. So there will be one hidden layer. In the end, I will get an output like this one. Okay. This is the architecture we are going to create here, guys. This is called as Y now. So within the convolution block, guys. So I already told within the convolution block, there will be three operations will be performing. So we have to add the three layer convolution 2D. Then second operation for the layer is pulling. So I'll be adding a pulling layer, and then I'll be adding something called as padding layer here. Okay. So padding layer, and this kind of a one block, I'm going to create. This is one block. So this is block number 2, and this is block number 3, guys. All right. So these three blocks I am going to create this kind of a three convolution block, and then I will be flattening my operations, and then from the flattening, I'll passing my entire operation, entire data features to my artificial neural network. So this is my flattening layer. So you can say this is conv block 1, this is conv block 2, and this is conv block 3, guys. All right. So after three such convolution blocks, then I have a flatten layer here, flattening, and then this is my ANN, guys, artificial neural network. Okay. So this is what we're going to create it. Which padding is used, 0 or 1? Padding is same, guys. Padding is same. Valid means it is the same padding. Valid means same padding, same. I spoke about same, right? That is padding is valid. By default, it will try to take the 0 padding, guys. So it is actually we are saying valid equal to valid means by default take the padding. Okay, this is what we are talking about. All right, guys. So everyone is clear now. So what kind of architecture we are going to build? So let's try to understand how to build this kind of a layer now. So let me draw the things. So convolution block 1 will be there. Convolution block 2 will be there. Convolution block 3 will be there. This entire part will become entire my convolution block. This conv block will be there. So block number 1, block number 2, block number 3. And within everything, guys, within every operations, there will be 3 operations happening. And then this will be my flattening layer, and this will be my ANN in the end. Okay. So let's try to understand how to build the model. So I am calling my sequential model. It is same model, guys. Okay. For everyone. So let it be RNN, let it be a CNN, let it be ANN. For all the kind of a convolution neural network, artificial neural network, recurrent neural network, model gonna be same in the Keras, sequential. Then, guys, what I'm going to do now, I'm going to create this kind of a line here. This is regarding this convolution block number 1. Let's try to understand what I'm trying to do. Now, once I've created this model, I'm going to add my layers, right? One by one, all the layers. So you guys already know what are my layers, right? Convolution layer, and then my pooling layer. Okay, pooling layer, and then my third layer is padding layer, guys. And when we talk about, guys, this kind of a batch normalization, okay, so this batch normalization, I can put it here. Let me denote that with a different color now. So that batch normalization layer, I can put it somewhere here, means here, or I can put it here as well, guys. So first, you don't have to add this batch normalization. So first, try to create a raw model without the batch normalization, guys. And once you are trying to create a batch normalization without batch normalization, then you try to see how your model is performing. Then you can add back this one-liner code. I will explain you. Don't worry. Let me write the things. Let me write the things and let me explain you the things. What we going to perform here. Let's try to understand one by one. So guys, everyone is now comfortable that the first part what we're going to create is we're going to create a model first. Then guys, as of now, for the meanwhile, try to create this model dot add batch normalization as separate. So first try to hashtag them. So it will become comment. Then first create a raw model. So we create a raw model actually. A raw model will be without batch normalization actually. Okay. So I am going to create model dot add. Then I'm adding my convolution 2D. So convolution layer. Okay. So first layer is convolution layer. Convolution 2D. This is the layer I am offering here. And you can see here I have added 32 neurons here. 32 neurons. Kernel size. Now with this, what is this kernel size? Can anyone tell me why I am building this kernel size now? Looking at the yesterday's explanation, why I am building this kernel size? What is this kernel size tells us, guys? Can anyone tell me quickly? What is this kernel size and what is this talking about? Can anyone tell me what is this kernel size, guys? And padding I am saying valid. Then activation function I am taking ReLU, guys. And then I'm passing my input shape. If you remember our images, whatever images we have taken, it is the shape of 256 into 256. And then again, since these are the color images, I'm saying 3. Number of channels equal to 3. These are the rows, these are column, and these are channel, guys. All right. So when I'm saying here, guys, kernel size equal to 3 by 3. So what does it mean? Kernel means size, sub image. Yeah, Kamesh, you are correct. But what we can see is kernel is nothing but our filter. Remember our filters? By applying the filter, we are trying to extract the features, right? Features. And these filters are applied over the matrices of the images, right? These images, they get converted into these matrices, right? So these 3 matrices will be created since it's a color image. So that is why we are, yeah, Kamesh, correct. So this is what the filter we are talking about, guys. And whatever this filter I am trying to take, that filter size is this way, 3 by 3. So this is 3, 3 filter I am applying, guys. Okay. So number here will be randomly generated initially. And then later on, we going to understand what the number is there, right? We're going to learn these things. All right, guys. So everyone is able to understand. So what I have done here, first thing what I am trying to do is here is I am adding my first layer. The first layer is convolution layer. I am taking 32 neurons, guys. All right. I'm taking 32 neurons, kernel size I'm taking, padding I am taking, activation function I am taking, then I'm passing my input shape, guys. Sir, what if we don't write padding equal to valid? What it will be used? So if you don't write padding equal to valid, guys, it will try to take the by default padding equal to white means what I am trying to write here is I am saying please include the padding here. Please include the padding operation when I'm saying padding equal to valid. If you want, you can check the by default value. I guess by default value will be the 0 padding. If you don't want the 0 padding, guys, you can change the padding to 1 padding or you can change the padding to the same padding. You already know, right? So when I'm trying to say padding equal to valid means I am asking that please include the padding operation as well. When you're trying to convolute the operation, at that time my entire dimension will be getting reduced, right? So I'm trying to gain back the dimension and then I'm also applying my pulling operation. Okay. So that's the logic here, guys. That's the logic what I'm trying to perform. All right. So hope I am able to answer your question. Okay. So guys, this is where I have added my layer of convolution operation. Then guys, second layer, what I'm going to do is, as of now, I will not add a batch normalization. I'll tell you when to add batch normalization. So first, then I will add padding equal to true means I have already added my padding operation. Then guys, I am adding my pulling operation. Here we are taking max pulling 2D. So model dot add max pulling 2D. Okay. Max pulling 2D, guys, and then max pulling 2D, and I am passing my again pulling filter 2, stride equal to 2. You can see here, guys, stride equal to 2 means it will try to shift back 2 cells every time. And padding also I am saying valid also. After pulling also I am trying to make a padding equal valid. Okay. So this way, guys, I created my one block number 1 here. Okay. So this is my block number 1. Same thing I will copy paste below, guys. Same thing I am going to copy paste below, and same thing I will copy paste here as well. Okay. Same thing I am going to. Yeah. Okay, Shri. No problem. Okay. So guys, same thing I am going to copy paste. Let me rub the things and tell you now. So this is my block number 1. You can check here. Now same code, like I first added my convolution layer, then I created my padding equal to valid. Then guys, as of now, don't go for this batch normalization. Then add your add the max pulling. Then I'm writing my pulling size 2 by 2 here, kernel size 3, and then stat equal to 2, padding equal to 2. Since this is the first time we are taking the image here, that's why I'm created a image shape. Okay. Then guys, once I have created this input shape, that's it. The input shape we are given. And then guys, in the next time, you will not see this input shape parameters here. Okay. So second time also, then I am copy pasted the same thing. Third time also I copy pasted the same thing. So this is creating my convolution block number 1. This is creating my block number 2. And this is creating my block number 3. Now, what is the change happening, guys? Only the number of neurons are changing here. So same line I copy pasted. Only the neurons here taken 32. Here I am taking 32. In second block, I am taking 64. And in the third block, I am taking 128 neurons. Okay. And then, guys, once I created my entire convolution block, let me rub these things, guys. This entire portion is now copy pasted. Same thing is there, guys. Just added a 2 line of a code, model.add, convolution operation, kernel size, padding, activation function. First time I am giving input shape. Otherwise, you don't have to give an input shape. All right. So everyone understood what kind of operation I have done here, what kind of layers I have added, and then batch normalization, then max pulling, guys. And again, in the max pulling, you have to write the pulling size, like what kind of a filter you are trying to apply. Strides you have to write, and padding valid I am writing, right? Same thing I copy pasted. Only change I have done in the number of neurons. First, I have taken less neurons, 32, then 64, then 128. Why 128, 32, 64, guys? Because whenever I am trying to apply at level 1, at level 2, and level 3 kind of a convolution operation, right? Convolution operation means whatever the features are I am trying to take, right? If you remember our dog feature, first from the dog face, okay, from the face of the dog, I am trying to take the eye separate, ear separate, and then I am going to level 2 again. Within the nose also, I am trying to take the nostrils, mustache, whiskers, everything, right? So that kind of a detailed, minute level I want to go. So that is why I'm trying to increase my neurons here, right? So once I created my convolution operation, guys, end of this, I will be getting my entire features, right? Entire features will be rendered. So I am trying to apply at level 1, level 2, level 3 kind of a features. And by applying this kind of a filter, guys, I am able to get the features end of this block. That features I am going to create here in the flattening operation. This kind of a flattening operation I am performing here. All right. So let me rub these things and see here model.add, just say flatten. That's it. Your flattening layer will be added, guys. Then this year we started encoding our artificial neural network. I am saying model.add. Now I am not saying convolution 2D or max pulling. I am saying dense. Dense means our normal artificial neural network. This is my input layer here. So I am saying 128 neurons because the last neuron was 128. So that many minimum features will be generated. Then I am passing my activation function. Dropout don't add as of now. As of now, in the first iteration, don't write dropout, guys. And once I pass my pass my input layer, guys, I am adding my hidden layer 1 here, hidden layer 1, which is 64 neurons activation function value, and this is my output layer. And where I am taking only one single neuron, because one single neuron is sufficient for me to give whether it is a dog or cat probability, and max of that will be my final y hat, guys. All right. So everyone understood how to create this convolution neural network, guys. So same code I have copy pasted 2 times. This is the first time, second time, and third time. Only changes now number of neurons I have increased here, and then I have flattened my operation, and then I have created my artificial neural network, right? So this kind of architecture I have created, guys. Now what I am going to do is I am going to check my summary whether this model is created successfully or not. So then I'll try to train the model. Okay. So let's check the model summary, model.summary. So you can see here sequential. First, you have created this kind of a 254 into 254 by 32. This kind of a convolution 2D layer you have created. Then the batch normalization layer and the max pulling layer. So this 3 line of a code will create one block. Such second block it is created, and such third block is created, right? So this is what we are able to understand. And then we have a flatten operation here. and then we have our artificial neural network, right? So guys, when I'm trying to do a flatten operation, now look at the parameters which are getting generated, 800, then 1000, 18,000 parameters, right, at the second block, and the end of the third block, 73,000 parameter, and then guys, 1,47,000 around parameters. So you can see here the total parameters which are getting corrected, right? So it is more than 1 crore, I guess, right? 1, 2, 3, 4, 5, right? These are only 4, 5, 6, and 7, guys. More than 1 crore parameters are getting generated, trainable parameter, right? And this is non-trainable parameters are 448. So you can understand that how many kernels, how many filters, and how many weights and biases are getting generated, guys, right? So this is my entire model summary. Then guys, just like the artificial neural network, I am passing my optimizer. So model.compile, optimizer Adam, then loss function, binary coarse entropy, and matrix accuracy. Okay, once you compile your model, right, you try to tell which optimizer to use, which loss function, and how to judge the accuracy. You can start training your model. Model.fit, pass your trained data set, number of epoch. I am taking very small epochs as of now, and validation data set, guys. That's it. And we will have a 10 epochs now. So within the 10 epochs by batch size, which we have generated here, right? Remember when we created this trainable site, batch size we have taken 32, but 32 images will be taken at one go. And this way 10 epochs will be created, guys. And end of this epoch, we can see here, what is my accuracy? 97%, and this is 80%. So which is good accuracy. This is train accuracy. This is test accuracy. So which is very, very good accuracy, guys. You can check here the accuracy loss function first. This is the accuracy, okay, train and validation. But you can check here what is the problem happening. My accuracy out here is 97% in the training, and the testing, guys, I am getting 87% accuracy, right? So now can anyone tell me what is the problem happening actually here? So it is a good model or bad model? Raw model I have taken here, guys. Is it a good model or bad model? What is happening here? Awesome, awesome, Sanam. It is a overfitting happening. Why overfitting? Because if you try to look at this train accuracy and the test accuracy, guys, there is a gap actually. So this gap is very huge gap. So means my model is overfitting. Overfitting. When I'm trying to pass the unknown images, it is trying to fail to recognize this image, right? It is failing in the testing phase. So because testing accuracy is very less, but my training accuracy is very high. So that is why I told you first go with the raw model, guys. Then what to do? What operation we have to perform now? So we'll go back now to our model. Now we'll go back to our model, guys, and then we'll start adding. Okay, that's why I wanted to show you before batch normalization, after batch normalization, after adding the dropout, what will you the effect? The first graph which I have created here, okay, whatever model I have trained here, this was without batch normalization, without any dropout layer. Okay, this was the overfitting was happening, and that is why. And the second step, guys, I have added model.add batch normalization here after every convolution block. And then this here also, that the third time I have added model.add batch normalization. And here also, if you see here, I have added a 10% dropout. Model.add dropout 10%, model.add dropout 10% after hidden layer as well. Then guys, then I will try to retrain my model. Now check the accuracy. Okay, now you can check the accuracy. Now look at the accuracy, guys. Okay, so this was the first time accuracy. After that, I applied my entire train test validation, guys. And now you try to see here, this was the huge gap out here before the entire dropout validation, guys. And after I applied dropout validation, guys, you can see here. No. It's not like that. You can add it at any point of time, but it will be since because we are trying to do a batch normalization, right? And why we are trying to add it after that, right? Because we already normalized our data. If you try to look at this data here, normalize process. So before we even start building our model, we already normalized our operations, right? So that's why now it is not able to matter anything batch normalization, right? So batch normalization will matter only when I am trying to get a overfitting. Actually, otherwise I could have added this after the max pooling. Okay, so that your logic is correct, Sanam. But why I am added? Because I previously normalized my matrices, right? Here before even we start building our model. So that's the reason I have added just beside after this one. Okay. Now it is a really good catch that you can add after the pooling also. Okay, this will also perform better. So guys, then we can see after normalization and after the dropout, now your entire accuracy is now getting close to each other, and you can check this one. Entire gap has been reduced, guys, right? So now let me test the image. So what I am going to do is, like I have written here also how to reduce the overfitting, guys. What are the methods to reduce? One, you can do a dropout. One, you can apply L1, L2. You can do a data augmentation. Okay, and then we can reduce the complexity of the model, like whatever layers we have taken, 3 convolution blocks we have taken, we can remove them. That is one more method, and then drop out method. Okay, so this way you can reduce, guys. Now what I am going to do is I am taken one random image here, this cat image. I am importing this image using the CV module. Okay, and by using the CV model, I am trying to import this one image cat.jpg, guys. This is what the image look like. Now I'll try to pass this image and I'll try to check whether my model is able to detect this image correctly or not. Okay, so the size is this one, so we have to resize this because our model initially when we built it was 256, around 256. That's why I'm reshaping this image, guys. cv2.reshape, and then I'm reshaping it to 256. Then I'm passing as a test input. Then, guys, I'm saying model.predict, pass this test input, and now we can check. Correct, so it has given me 0. So this is correct, guys. 0 is cat and 1 is dog, right? First folder is for cat, second folder is for dog. That's why it is given 0, means it is correct prediction it is doing. All right, guys. So this way simply you can build your simple classifier. Any doubts, guys? Any questions as of now? How to build your simple classifier? How we have created entire thing, how we are able to handle this huge gap between the train test, overfitting, what kind of layers we have added here. These are some ways I have already written here, guys. All right, and how to build the entire model around it. All right, guys, any questions, any doubt before we move ahead and try to tell you the next complex model, which will be the supervised model, which will be a pre-trained model. Yeah, guys, any questions, any doubt? Or should we go ahead now? Okay, so I guess no questions. Everyone is comfortable with the entire code. So let's try to move to next code, guys. What I'm going to showcase you is how we can build one more supervised training model, like you guys were asking. So whatever pre-trained model are there at that time, if you try to take that pre-trained model, how to create that pre-trained models, okay? How to create that pre-trained model and where to make this entire pre-trained models weight false and all, right? So that kind of a thing. So guys, I'm not going to detail. Actually, I wanted to run one more object detection model for you. Just for the showcase, I'll try to tell you. Like if, let's imagine that you are trying to build a one kind of a face recognition kind of a model, right? So here there will be multiple categories, more than 2. So for that purpose, what I'm going to do is I'm going to use a pre-trained model. This pre-trained model, guys, I'm using VGG16. Okay, let's try to understand what is this VGG16. VGG16 model I'm using, guys. This is a pre-trained model which is available in the TensorFlow and Keras, guys. TensorFlow and Keras. This is already a built model by the Google. Okay, so what is this VGG model? VGG model stands for Visual Geometry Group. Okay, Visual Geometry Group, guys. This is the name, and this model has a 16 layers actually. Like in if you have seen in our earlier model, this dog cat classification model, we have built in only 3 blocks, right? 3 blocks of convolution, and then we built plus our artificial neural network. This was our architecture, right? In total, we have only 4 layers, right? If I try to understand. Then guys, this VGG16, which model I am going to use, right? Visual Geometry Group 16 model. So this 16 model has 16 convolution layer, guys. 16 convolution layer. So that kind of a vast model it is. Okay. This is a very depth model which has a 16 layer of convolution neural network. And by using this convolution neural network 16 layer, guys, it is already pre-trained. Okay. It's already pre-trained on the data. We're going to use this pre-trained model. And then we're going to use this pre-trained model, guys, and going to customize this for our own category. Okay, we're going to customize this own category, how to perform this customization and how to use this model and how to train the only part of the model for our data. That I will try to showcase you very quickly. Okay, so guys, here this is the same part which we're going to perform. Here I am going to import my packages. Let me tell you the packages one by one. I am importing Keras from the Keras. I am importing my input layer, dense layer, flatten layer, lambda layer. Okay, so we'll understand what is this lambda layer does afterwards. Then guys, from Keras model, I'm importing my model. Then I am from the Keras application, I am importing my VGG16 model. Okay, so this is the VGG16 model which I will be using now. This is a pre-trained model. Then from VGG16, I'm importing my pre-processing input, and then I'm also importing something called as from Keras.processing, import the image, and then I'm importing from the image, I'm importing something called as image data generator. Now this image data generator will help us to create a train and test validation dataset paths, and which will be provided to my entire VGG16 model. Okay, and then the normal model, sequential, this model which we trying to use, then NumPy guys, and my matplotlib package. Okay, this is what I'm going to use. This global package is used for providing the path guys when I'm trying to create the paths of different directory. For that reason, we use globe application. Okay, globe package. All right guys, so this is what I've done. Now I've taken the images of 224 by 224 size, and then I'm creating path data set. I will be creating one folder data set. Within that, I'll try to keep two folders, train and test, and within that guys, I'll create a individual folders. Individual folders, the one folder belonging to one category. Okay, so what I'm going to do is I'm going to create a 4 folders here, and within that 4 folders guys, you can keep your relative, your friends face photos, face images. Okay, so I'm going to create this kind of a 4 folders, and within that we'll try to keep a individual face images. Okay, and once you pass this kind of a face images folder for the training purpose to VG16, you will be able to perform a facial recognition part. Okay, so this is what the pre-trained model will try to use and perform this task. So guys, first I've created this training path, then I'm going to import my VGG16 model directly here. So VGG equal to VGG16, whatever VGG16 model we have imported guys. Then I'm passing my input size. So what is the image size? We have created is this variable parameter. Then weights I'm taking ImageNet. So let's try to understand what is this weight ImageNet means. Guys, there is an ImageNet data set actually present. ImageNet data set. This ImageNet data set has a 10,000 categories. More than 1,000, not 10,000 actually. More than 1,000 category data is there. These many classes are there. More than 1,000 classes are there, guys. And for every class, they have a 10,000 images. For every class, they have a 10,000 images. And this kind of a vast data, this kind of a vast image data they have on this kind of a data set, guys. On this kind of a data set, this ImageNet, this VGG16 model is trained, guys. This VGG16 model is trained on the ImageNet dataset, and this dataset contains the 1,000 categories, guys. 1,000 categories, and for every one category, they have a 10,000 images each, right? So this kind of a huge dataset is there. On that dataset, this model is already trained, guys, right? So that is why we are taken weights equal to ImageNet. Means that denotes that whatever this ImageNet dataset is there, whatever these 1,000 categories are there, this category training is already done, and that weights we are taking here. Okay. This is what very important thing is how you try and take the pre-trained model, guys. So we are taking pre-trained model. I'm passing my input shape. Then weights equal to, you have to take whatever weights we have trained on. So when I'm trying to showcase you guys, also the YOLO model at that time also I will try to showcase you. In the YOLO, we have taken Pascal, kind of a Pascal, and one more data set is there. I'll explain you. That data set weights we are trying to track. Okay. Pascal data set was there, and one more data set was there, like Pascal DB was there. I'll tell you, I have written all this data set model's name, and that data set is trained. We have taken that train model for the object detection. Okay. So that thing, and then guys, this important parameter is there. Okay. Include top equal to false. So what will happen when you try to include this parameter here? Then it will try to understand that you are tracking a pre-trained model. Pre-trained model you are tracking, and you don't have to train that model. Don't train that model from the scratch. So this is what it will understand when we try to process. Don't train the model from the scratch, means don't train all the layers of the model, because what is going to happen, whatever these 16 layers, the model will be there, right? 1 to 16 layer, and then we'll try to add our own customization layer here. Okay, my custom layer I will be adding here. So, and then in the end, we will have an artificial neural network, and after that, we'll get a y hat, our output, right? So this is the model will be there. So whatever the custom models, these custom layers will be added. Only those layers will get trained. Okay, only those layer will get trained, and whatever this VGG model is there, right? VGG models layer 1 to 16, this will not get trained. Okay, this is what I am saying by including include top equal to false. By this command, guys, this parameter I am including this, that whatever the top models are, top layers are there, this layer should be freezed, and only whatever custom layer I'll be passing, only that model should be getting trained, right? So this way I can retain my original weights and this original pre-trained model, right? So any doubts, guys? Any questions? Are you able to understand that what model I've created here? This model I've created simple 3 parameters I've passed. What is the input size I'll be passing? What are the weights I'm taking? Means what kind of a model which trained on the ImageNet dataset, and include top equal to false. This is what I've written, and I'm calling this as a VGG model. Okay. So once I call this VGG model, guys, then what is the next step I'll be doing? Let's try to understand now. So I have downloaded this entire model from this TensorFlow, guys. And then what I'm trying to create for layers in the VGG.layers, I'm saying trainable layers.trainable equal to false. By this way, I'm trying to keep my existing weights. I'm not saying that don't try to train these layers. Okay. Whatever these layers are there, these VGG model layers, don't train them. This is what I'm trying to do here. For layers in VGG layers, layer dot trainable equal to false for every 16 layers. Okay. Then guys, I'm trying to pass my train data folder here, and then I'm trying to pass my customization layer. Okay. So when you try to check the layer, I have created a 4 folders here and 4 category of persons, face, images I have passed in and tried to store here. Okay. Then guys, what I'm trying to do is I'm adding my own flatten layer, because so whatever this entire layers will be there, whatever this entire layers, when we try to pass the image, out of that, whatever features will be coming, we'll try to flatten this feature, right? Same thing. And then I'm trying to add my own layer here, dense layer. So which is the dense layer? Within that, we're trying to take the neurons, which is equal to number of category. How many categories are there? That many categories plus one. I'm trying to keep it. And then I'm trying to take that as the output, right? So because my output should be that many folders, whatever folders I'm trying to train for the categories, right? And then activation function, I'm taking sort mass because we are trying to train on multi-class classification, right? So this way I've added my own layer, guys, and then I'm calling this as the entire model. Model dot model equal to model, input equal to VGG input, and then output equal to prediction. So this model, prediction model, okay. This way we have customized your model, and then we can check the summary, guys. Now we can check the entire 16 layers will be there. This layer number 1 to 16, all the layers are there, previous layers, and then this is our customization. So my flatten layer and then my dense layer. So which is dense layer equal to 5 because my 4 category data plus 1 neuron I have added, and this is my last customization. And other all these 16 layers, whatever these previous 16 layers are there, these are from the VGG model. Okay. So you can check the summary. Now, after looking at the summary, guys, you can check how many parameters also created. In total, you can check here the total trainable parameter, which are more than 1 crore parameters. And then, guys, we trying to compile same way like we compiling our model for the categorical cross entropy, loss function, optimizer, Adam, accuracy. Loss function I have taken categorical cross entropy because this is the multi-class classification. All right. So then, guys, I'm trying to pass this my model to my image data generator, training and test data generator, like we discussed already. You just have to provide the path of the data, batch size, and our mode categorical. Okay. And that's how it will be able to take the image data. Then we try to say model.fit.generate. That data will be generated, and then I'm passing my entire thing to model.fit. Fit generate means, so now this time, whatever the data is generated through the testing and training folder, that will be passed on to my model here. And number of epochs equal to 5. I have taken validation data set, train data set, everything I have passed here. There. My model training will set. I am taking very simple 5 epoch only. And with the 5 epoch, I will try to understand how it is able to perform the prediction. Okay. Then, guys, once the model is fitted for 5 model, this training is generated now. And you can check the accuracy now. Okay. Accuracy now is 100%, guys, which is wrong actually. So 100% and the validation accuracy is getting very less. Any reason, guys? Why I'm getting this kind of a things? Any reason? Anything? Anything you can come up with? What could be the cause that I'm getting training accuracy 100%, but validation accuracy I'm getting only 25%. You can check the huge gap is there, right? Train and test accuracies also you can check, right? I'm getting 100% in training, and in the testing, guys, I'm getting very less accuracy. So what could be the reason, guys? Can anyone tell me why this is happening actually? So guys, understood how to build this model, how to take the data, right? So only problem out here is, if you can, before I explain you the reason, guys, can anyone tell me, like, you guys already understood, right? How to download your already pre-trained model, keep the weight, include top equal to false, make all the layer freezing, perform the freezing of all the layers, like trainable equal to false, then create your separate folder for 10 test, and then add your own layers like flatten layer and your dense layer, and then take the final model, then check the summary. And after the summary, guys, you can create here the model.compile and model.train here, right? This is what I have done. Now, if you try to look at this, guys, so whatever the test data and train data I'm passing, I have found 5 classes, right? 5 classes. And then if you try to look at the images, how many images I have found out, right? For these 5 classes, 10 images, and for testing purpose, 4 images. So now tell me, looking at this situation, tell me, like, why I'm getting this kind of a prediction, right? So whatever the accuracy I'm getting here in the training, I'm getting 100%, but in the testing, I'm getting very less accuracy, around 25% only, right? So what could be reason now? Tell me, guys. Looking at the entire situation, can anyone come up with a solution that why this is happening? Where I have taken a very nice model, VGG model, VGG model's accuracy is like more than 80%, guys, actually. If you try to check in the details about the VGG model. So, but still this model is failing out here when I'm trying to customize for my own face data, face recognition data. So what could be the reason, guys? Quickly, come on, guys, tell me now. Quickly, what could be the reason? I've shown you entire code, right? How to perform this entire pre-training. Then what is the reason? Like why my model is failing here? Now you guys can see that there is a overfitting happening here. Complete overfitting is happening. So what could be the reason? Can anyone tell me? Quickly, guys. I have to start the topic, guys. Next model also. Please tell me fast. If anything comes to your mind. Normalization. Okay, normalization is missing. That's what you're saying, Amar. Yeah, guys. That's also correct, guys. Any other guesses? Like what could be the other reason? Less epochs. Yeah, awesome, awesome. Sanam, awesome. Amar, awesome. Nice answer, guys. Correct answer. Epochs are less. Normalization is not done. And there is one more reason, guys. One more last reason, which is very, very important reason. Can anyone tell me the last reason now? Why this kind of overfitting is happening here? Last reason, guys. Tell me. Then we'll try to move ahead. Less data. Awesome, awesome. Nisha Vanzari, correct. Awesome answer. Less data. If you try to take it, the data, guys, here. Initially, when I set it up this dog cat classification, at that time, guys, and let me check who's balancing the data. Yes, correct, correct, Nisha, correct. So what is happening is, guys, if you try to look at the data here, so when I try to customize this model, okay, and when I try to pass this data, right, you can check here. So when I'm passing, guys, I only pass the 10 images, means only 2 images I have given. Data set is not balanced. Awesome, awesome, Nisha. Correct answer. Correct answer. If you try to look at the categories, I have a 5 categories, and for each category, guys, I have taken only two images and one images for each category for the testing. Actually, this is the problem. Where in the dog cat classification, I have given 10,000 images for one category. Here I am taking only 2 images for the 5 categories. That's why total is 10, guys. So that's the biggest problem. Normalization is missing. Number of epochs are very less, and the normalization is not done, guys. So that is why I am not able to fit the model. But if you try to change this entire thing, guys, you will get a more model. Okay, at least try to take 100 or 200 images for each size of the data. Size of the data always matters. Yeah, awesome, Rahul. Correct. Correct. Now this is a really good example I wanted to give you guys how your model can fail. Okay. Yeah. If you don't freeze, then again your model, that is a no use then. Sanam, what will happen is if you try to do, if you let's take this example. So whatever things I am trying to do here, okay. So for layers in vgg.layers, layer.renable equal to false, right? So if you don't execute this command, or if you don't execute this command, include top equal to false, right? At that time, what will happen? It will become general model, like the weights we are taken, whatever this weights, ImageNet weights, right? ImageNet means it is already pre-trained on the 1000 category data. That entire learning will be passed on. Okay, there will be no learning. Your model will be very fresh then. So that will not help you because you have to train your entire model from the beginning, right? So guys, so I guess now everyone understood how we can train the things, what is important, what is not important. So how we can entirely achieve the things, right? So let's go to our next model, guys. Very awesome model, object detection. I am sure you guys going to like this model. Okay, so this is one of the latest model. Let me share with you guys this model. Okay, so guys, quickly, yeah, Sanam, Nisha, and other guys, Rahul, can you please quickly tell me that you are able to see my entire collab notebook, YOLO NAS? So let me execute this. Just give me confirmation. We can start executing this YOLO NAS model. Okay. All right, guys. All right. Thank you. Thanks for the confirmation, guys. Now what I'm going to do is, guys, thank you. Mohammed, sir, thank you. Everyone, thank you. So, guys, let's try to understand what I'm going to do here. Yeah. Nisha, okay. I will explain layer freezing. Okay. It is very, very simple logic actually. Let's try to understand what you have to do. Let me go back to that window actually. Okay. So see here, what is happening here, okay? So see here, what is happening actually, why I need to freeze my layers. Let's try to understand. So first, what I'm trying to do is I'm trying to take a one model actually, which is pre-trained. Now, pre-trained model means what, how you can understand this is a pre-trained model. So whatever this VGG model is there, this is already pre-trained and this has a 16 convolution layers. Okay. That's why the name is given visual geometry group 16. Okay. 16 layers are there. Actually, when I'm trying to take this model, guys, if you try to look at the weight, okay, this kind of a parameter, this weight parameter include the value equal to ImageNet. Means what? ImageNet is a data set, guys. It's a data set which contain 1000 categories, and for one category there are 10,000 images. Actually, that kind of a huge training is already done for this model, right? That's why I'm passing this kind of a include top equal to false means whenever I try to train the model, I don't want to train from the scratch. Okay, this is one thing. Then what I'm trying to do is whatever the layers are there, 16 layers, right? This VGG will have a 16 layers. If you try to look at the summary here, so what is happening? This is layer number 1, convolution block, input layer, convolution block, pulling block, convolution block. This way, my entire 16 layers are there. If you try to go back and try to understand this one model summary, see here. These are my entire 16 layers convolution blocks. Okay. So one is convolution 1, then pulling, then convolution 1, convolution 2, pulling on in between there is a padding layer also. All this kind of entire information is there. Okay. So what is happening is this is my top, right? And in the bottom, I am adding my flattening layer, and then I'm adding my own customized last layer, right? This last layer for my output, right? So that is what I'm trying to write, that include top equal to false means whenever I'm trying to take this model, I'm not going to include my top model for the training purpose. And then I have to specifically write that whatever model weights I'm taking, this ImageNet weight, that weight should not be changed. See, try to understand whenever we try to run the model. Okay. So very, very simple thing. My model, entire model look like this one, right? WX plus B, right? Weights plus biases. So what is here? X is given to me. X are my images, right? X are my images here. So what my model learns is my weights and biases. My weights and biases. This is what my model learns, right? Using the optimizer, weights and biases. Now, what I'm saying is whatever these weights and biases are there, don't learn from the beginning. So they have already learned that using this kind of a ImageNet data set. Okay. So that's what I'm saying, that whatever these layers will be there, 16 initial layers, I'm trying to take them layer dot trainable equal to false. So I'm calling for layers in the VGG layers, VGG dot layers. So whatever these layers will be there, I'm trying to take the layers and saying that layer dot trainable equal to false. By using this, I'm trying to simply freeze. I'm freezing all my 16 layers. Okay. 16 layers so that my model is remaining as it is. Its weights will not be changed. Because later on, what will happen when you try to train the model, you guys know already, right? So these weights and biases will be changed, right? It will try to learn these weights and biases, W and B, by using the derivative of loss with respect to weight and derivative of loss with respect to this C, right? This W and B, right? Weights and biases. By using the gradient descent algorithm, right? We are saying gradient descent, Adam, SGD, all these algorithm optimizer, right? So this is what is happening. That's why you have to pass this specific line, so that your model training does not happen from the beginning. Okay. So this is only two parameters you have to make it. One, this include of false, and this also layer dot rem equal to false. That's how you have to freeze your model. So once you freeze your model, your original model, this VGG 16 will remain same, and plus you will do your additional customization over here. Customization here. Customization is just the flattening, and one more layer I'm taking. That's it, and directly taking my Y tags. All right. So this is what is happening. I hope I answers your question. Okay. Yeah, awesome, awesome. This is correct understanding, Nisha. Though idle weights are already there, we just trying to understand our new data. Means new data which I will be passing is my own category data. Means my friends and my family members' pictures I am passing, and they should be able to detect that faces and pictures, like mine face, your face, right? This kind of face. That only that data we try to learn. I don't want them to disturb their 1000 categories which they already learned, right? This is what correct answer. Okay, awesome understanding. So, all right, guys. So let's move to our next model now, YOLO object detection model, and let's try to understand how these things works. Okay. So, guys, what is happening is this YOLO model. Let's try to understand what is this YOLO model. Okay. So let me tell you very quickly within 5 minutes what is this model, because we don't have much time to explain the entire architecture. In simple one slider definition, I'll try to explain you what is this YOLO model actually. So, guys, Nisha, can you please confirm that you are able to see my presentation, this slide, YOLO slide? Just put me the confirmation that you can see my YOLO slide, and then I can start explaining guys what is this YOLO model. Yeah, Mohammed, thank you. Sanam, thank you. Thank you guys. Rahul, thank you for confirmation. Okay. So guys, let's try to understand what is this YOLO model. YOLO model stands for you only look once. Okay. You only look once, guys. And this is called as single detection model actually. Single detection model. Let's try to understand what is single detection model, what is two-step detection model. Okay. So within 2 minutes, we'll try to understand guys. Okay. Within the 2 minutes, we'll try to understand what is this object detection model look like, and then we'll try to create a code for this one. Guys, what is this YOLO model? YOLO model stands for you only look once. Okay, you only look once. So what this you only look once says that, so let's imagine this is the input image you are passing. This is the image you are passing. In the image, guys, there is a one person is standing, one dog is there, one horse is there. Okay. So this image will go through the object detection layers. These layers will be there. And then, guys, it will be able to perform prediction here, like object detection. Object detection means it is able, you can see here the rectangle is created around the human, right? Out of the entire face, guys. Out of this entire image, it is able to detect the exact position of the human. And it is also trying to tell you the probability. You can see here person's probability is 0.6. Then it is able to detect the exact location of the dog, and it is also trying to tell you the probability of the cat dog, and also it is able to detect the rectangle using the horse, right? So this kind of a things is called as object detection, right? So when you pass here, it will able to detect here. Now why it is called as you only look once? Because, guys, it is trying to perform the prediction of this entire model using only once. Means whatever models is created, whatever this entire detection, this rectangle box is created, guys, this is called as my bounding box. Actually, this is called as my bounding box, and these bounding box are called as ROI, guys. Okay, ROI means region of interest. ROI, region of interest, because in this entire picture, guys, I'm only interested in this person, this dog, and this horse, guys. These entire rectangles are called as bounding boxes, and these bounding boxes able to help me to detect the object, guys. Detect the object, and what is happening is in the YOLO, it is able to detect the ROI, region of interest, only once. So it will not able to give you two bounding boxes. It will give you one bounding box. That's why it is called as you only look once. And why you only look once? Let's try to understand the architecture difference. Actually, this YOLO model has been introduced, guys, back in like 2018 only. And this YOLO model has the entire series of YOLO. YOLO has a brother, siblings, and sisters and brother, guys. YOLO V1 to YOLO V8. These many models are there. And recently in 2023, guys, they have recently passed on this YOLO SAM model, YOLO SAM, segment anything model, and the YOLO NAS model, guys. YOLO NAS. NAS stands for neural architecture search. Neural architecture search. Architecture search, guys. Search. Okay. This is what the NAS stands for, YOLO NAS. And YOLO NAS has a three variant. One is like medium, one is like small, and one is, guys, large. Actually, three variants are there for YOLO NAS also. There is an entire family, version 1, YOLO 1 to V8. Then there is a YOLO SAM, and then, guys, YOLO NAS is there. So what is the beauty of this NAS model, guys? YOLO NAS model is, why it is saying that YOLO NAS model, let's try to understand that this YOLO NAS model uses the architecture like this one, the artificial neural network, ANN, and by using the ANN and by using the CNN layers, okay, it is trying to build based on the guys custom input. Custom input means every time you can give an input, on that basis, guys, it will try to create a new architecture. The entire new architecture will be created, and then on the basis of that, entire object detection will be done. That is why it is called as neural architecture search. Means whatever input, whatever normal neural network architecture you will be passing, and whatever convolution neural network architecture you will be passing, based on that, guys, based on that, it will try to create a new architecture. And once the new architecture is created, guys, then it will try to perform this kind of object detection. This is called as YOLO NAS model. Let's try to understand. They are talking about something called as RCNN and YOLO model. Actually, why this YOLO model is called as you only look? Because you only look once, because it is has a region of interest, ROI. ROI means this bounding boxes. This region of interest is this person, this dog, and this entire horse, right? Because this entire picture, there are other objects, other things, but my area of interest is only these people, right? This object. So by using this kind of a bounding boxes, BB boxes, bounding box, I'll be able to create a region of interest, and by using this region of interest, I'll be able to detect my object. And this object detection is done only once, guys. Only once. That is why it is called as YOLO model. In RCNN, I will explain what is this RCNN model. So let's try to understand what is happening is when you try to pass this model, okay, this will be gone through the YOLO layer. What are these YOLO layer? Let's try to understand. These are my YOLO layer. There in the YOLO, guys, they will be using something called as like dark net. Actually, dark net model is there. Base model is dark net. Dark net as dark net 34. 34 layers are there. 34 layers that will have a one more layer here, resizing layer. This kind of a resizing layer they will be there. Then in the second, guys, it will try to take the features, and from the feature, it will try to perform a NMS algorithm. NMS algorithm, and after NMS algorithm separation, guys, it will able to detect this kind of a boxes. This kind of a boxes. NMS stand for non-max separation. This is algorithm, guys. Non-max separation. NMS algorithm. Special algorithm is there. The special algorithm, what it does is, whatever bounding boxes, what will happen is when we try to pass our algorithm, to this darknet 34. 30 darknet 34 means these are 34 layer architecture is there. Darknet 34. There will be plus some 20 layers will be added, and that will become a darknet 54 actually. That darknet 54 model is used, guys, in the YOLO. Okay, this YOLO model darknet 54. Darknet. Let me write it in correct way. The base model is darknet. Darknet 54 actually. So what is this trying to do is it is trying to use the Google Net actually. Google Net model is around 34 layers, and plus it is going to add some additional 20 layers, guys. And using this combination, okay, using this combination, they have created one model called as darknet model. That darknet model is a base, guys, here. Okay, so this will be a darknet model here, and that darknet model will pass to this kind of a three-step process. Okay, let's try to understand. Let me write here. Okay, so darknet I am writing here, guys. Darknet 54. It will have a 54 layers of convolution. Okay, the first image will go to darknet. From darknet, guys, it will come here. So this is the resizing operation. Operation number one will resizing. Then, guys, it will try to run a convolution neural network here, which will be able to extract the features. And for features, guys, once we extract the features, means what will happen? They will try to generate this kind of a bonding boxes. One box will be here, 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 one box. Let's imagine it has created 50 boxes. Okay, out of 50 boxes, how many boxes I am interested, guys? Only 3, right? Out of 50, I am interested only 3 boxes. So that 3 boxes were detected finally by this third algorithm, third step. Here in the step 3, out of these 50 boxes, whatever boxes will be generated. Okay, some boxes will contain the object, some boxes will not contain the object, but I am only interested in these 3 final boxes. That detection process, that entire detection process of my final boxes. Okay, so that will be done by my NMS algorithm. NMS, it is called as NMS algorithm. NMS, non-maximal separation algorithm, guys. Whenever there is a next time opportunity we'll try to dedicate entire our session for the object detection, object segmentation, and YOLO thing. So I will explain it. At least it will take like 3 to 4 hours to understand entire working, guys. Okay, so we'll try to understand. In short, I'm telling you, there is a darknet model. Darknet model will pass the picture. Then from the darknet model, we try to do a resizing. From there, it will try to come to a convolution neural network, guys. One more network, this layer 2. And this layer 2 will generate these boxes, guys. One model will generate the boxes, and one model will generate the probabilities. Along with this probability, what is the probability that there is an object present, right? So this kind of a boxes will be there, 50 boxes. Out of that 50 boxes, final 3 boxes detection will be done by my NMS algorithm, this third step, non-maximal separation algorithm. Then, guys, we'll get this kind of a result here. So this model is called as YOLO model. Okay, this is what the architecture of the YOLO model is. Okay, so we are going to implement this model and going to showcase you the entire object detection process, right? So let me show you this one now. I think this is a good introduction. So what I am going to do is here, I am going to run this model simultaneously with you guys. Okay, with the only 5 to 10 lines of code, we'll try to download this YOLO NAS model, latest model, which is just released 3-4 months back. So what I'm trying to do for that purpose here, so I'm going to install this library. Pip install super gradient, guys. I'm going to run this library, and this super gradient library contains this YOLO NAS model. Okay, so this there is a organization DAISY. There is a organization. They have developed this YOLO NAS model. Okay, they have kept that model in the super gradient library, and this super gradient library, guys, uses the PyTorch model. See, this PyTorch is a framework generated by the Meta Facebook. Okay, so first model which we have seen, they were based on the TensorFlow and Keras. This model, guys, now it is based on this entire super gradient model, which is based on the PyTorch. Okay, so guys, moment I'll try to run these things. Okay, let it run. Now once it is run, it will be able to successfully tell you. So and we will be able to install this library. Since I already installed, guys, it is saying that you already satisfied the libraries and your entire collection is already ready. And then it from the collection, it will try to conclude everything, and then it will try to showcase you. But for you, it will not show like this one. It will try to install all the packages. Okay, so since I already installed this, that's why it is trying to showcase you that condition already satisfied, requirement already satisfied. So let's wait for it, and it will finish its setup. And then first step is we're going to install this super gradient library. From the super gradient library, that's the second moment, it finishes the entire installation. What I'm going to perform is I'm going to import this YOLO NAS library. Okay. Okay, the entire processing has been done, guys. Now, so let's try to go to the next step now. So guys, next step will be Now I am trying to download my model. Okay, model training I have to do, right? So I am going to download my pre-trained model for super gradient dot training. Okay, from super gradient dot training, I am importing my models, and my model equal to this YOLO-NARS large model, guys. I told you there are three variants. One is small, medium, and large. I am taking large model. Okay, so what I am saying is model dot get. Okay, from this model function, model dot get YOLO-NAS large L. YOLO-NAS large, and pre-trained model is Coco model, guys. Coco. So let's try to understand this Coco data set is there. Again, this Coco data set is, guys, same like the ImageNet data set. This is Coco data set, also trained on some kind of a 1,000+ category of the data. And for one category, like there will be 1,000+ images will be there, 10,000+ images. And this kind of a Coco data set also exists, just like the ImageNet data set, right? And there are multiple thousands of categories are there. So this YOLO-NAS model, guys, it is already pre-trained weight. You can see pre-trained weight equal to Coco. So I am taking Coco model. There is also Pascal VOC is there. Pascal VOC is there. Pascal dataset is there. Then Pascal Coco is there. MS Coco dataset is there. And this Coco dataset. There are 4 to 5 datasets. I will explain you meanwhile. Okay. So I am taking my YOLO-NAS large model. How I am taking, guys? From super gradient library. Super gradient library I installed. Then I am taking model function. From model function model.get. I am passing the name of the model YOLO-NAS, YOLO_NAS_ large. Okay, and pre-trained with Coco. This is what I'm trying to do now. I will try to run this model. Okay, now let me run this thing simultaneously here. Okay, guys. So it will try to install this entire model, and it will try to save it in the variable name YOLO-NAS large. Okay, this is what it is going to perform here now. So let me run this thing now. I'll try to run this. This is a pre-trained model, YOLO-NAS model, latest model, guys. One of the best performing model. Okay, one of the best performing model in the latest arena in the object detection, guys. One of the famous state-of-art algorithm. Okay. So let's try to understand. We have downloaded the first thing. What I've done, I just simply install the pip install super gradient library this version. Then once it is able to install, you will be able to see this entire thing. Then I'm trying to run. Okay, this is successful. So from super gradient, I'm importing the model and saying model.get YOLO-NAS large pre-trained but Coco, guys. This is what I've done. Second step. Then, guys, in the third step, now what I'm going to do, let's try to understand here. So I'm going to call one picture here. Okay. So model inference. Directly my modeling thing is done, guys. Only 2 lines of code, my model is done. Let's try to understand what I'm trying to do here. Okay. I'm going to take this URL now. If you try to look at this URL, guys, this URL is about the some peoples are doing party. Okay. I'll try to showcase you this one. Don't worry. I'll try to run this URL actually. And this URL contains one picture, guys, where the people, some students are doing party. So you can see this URL here. So there are college friends here, and then they are trying to do a party. There are cold drinks. There are buckets of popcorns. There is a music system out here, guys. There is an entire system. There is a chair. There is a pant, shirt. So we'll try to pass this picture, and we'll try to understand, guys, by using passing this picture, whether my model is able to detect the people, my model is able to detect the bottles, my model is able to detect the bucket, my model is able to detect the picture, entire picture of. Okay. So this is what I'm trying to perform now. So for that reason, guys, I'm trying to pass this URL. Okay. How I'm passing URL? I'm creating one variable URL and then passing this entire URL. Okay. This URL I have stored here, and then I'm passing this URL, guys, here. So a dynamic picture I've taken from the URL. Okay. This URL, I've shown you this picture. People are doing party. Now, once this URL is stored in the URL variable, I'm calling my YOLO-NAS module. Okay. YOLO-NAS large model I'm calling. Then I'm saying dot predict. I'm passing my URL, guys. Okay. I'm passing my URL. Then I'm saying confidence score. Now, what is this confidence score? Try to understand. I'm saying confidence score cutoff as 0.25 means. So whatever image I will be passing, within that image, there will be different objects. So that object detection boxes will be created, right, for every object. If that detection object's confidence score, okay, confidence score means probability score is less than 0.25. If less than 0.25, don't take that box. Okay, don't show that box. Don't share. This is what I'm passing here. Confidence score equal to 0.25. This URL I'm passing. I'm saying YOLO-NAS.large.predict. Okay, this is what I'm passing. Then I'm saying show. So the moment I run these, guys, what will happen? It will try to take that URL. It will try to take that picture, guys, and it will try to run. I will try to run in front of you only, and let's see the entire detection will happen, guys. Amazing detection. It will try to perform. It will try to detect each and every minute detail. Now you see here. This is what the prediction result within the fraction of second, guys. You have seen that only one line of a code I can see here. So if you try to look at the analysis, guys, it is able to detect the person out here. It is able to detect the second person, and look at the confidence score, guys, 98%. It is able to detect the cup. You can see here the bowl is detected, right? Bowl is detected, bottle is detected, 94% score, right? Bowl is detected, one more bowl is detected, the cup is detected, right? Entire, it is able to detect even, guys, chair. chair, this person's hair is also detected here. This person's hair are getting detected, okay, hair there with the confidence score, and then entire faces are getting this person, 1%, 2%, 3, and let's try to understand, like it is able to detect the entire TV also. See here, TV with 62% confidence, it is able to detect the chair as well, guys. See here, couch, it is able to detect the sofa, it is able to detect the bowl, it is able to detect the cup cone, everything, as everything it is able to detect with that high accuracy. Okay, so that kind of amazing model is there, guys. Within 3 line of code, we have taken this model and we are implemented. And this is not about the image data. You're saying it's okay when we are trying to pass the image data. How about then, guys? A video. Let me pass one video also and I'll try to showcase you. Let me show you that I am trying to create one input path. Input path, I am going to save one video. Okay, I am going to upload one video here. So let's imagine this video I am going to upload here. One video will be uploaded, and then, guys, from this video, okay, it will be able to give me, see this video I am going to upload here. Okay. Within a moment, it will upload the video, guys, and I'm going to showcase you what is the original video, and then on the basis of the video, it will accept as the input, guys, and it will be able to give me an entire prediction on that video. Okay, so guys, you can see here. Okay, so it will generate this video here. It will get populated here within a minute. And then I am going to create one output path here. So here only I am going to create one output path. And whatever video I am passed, guys, it will be able to detect that video. On the basis of video, it will detect the object, guys, and it will be saved by using one result called as detect.mp4. Yeah, detect.mp4. So let's refresh this one. You can see the student walking video is there. Let me show you that video, guys. What is this video is all about? And then I'll try to showcase you from this video how we can understand the entire prediction done on the video. Okay. So this is the original video, guys. Let me run this video and showcase to you. The students are walking in the colleges along with their backpacks, and group of students are walking towards the college gate. Okay. So this is what the video is all about, and we'll try to understand, guys. See here. Everyone can see the video now. So some students are walking here, guys, and they are walking towards the college. They have a backpack, they have a books, they have a cell phones, they have their purse, individual purses, and there will be door, there will be person coming up, everything will be there, right? So guys, this kind of an entire detection process, this kind of a video I am going to pass now. This I have already uploaded. If you see this student walking video I uploaded, guys, I am passing this input path and output path. That guys, what I am passing is I am going to pass something called as output detected.mp4, and this entire thing I am taking as a GPU here. Then I am passing to this one. YOLO NAS dot last to device means GPU dot predict. I am passing my input path, guys. Okay, this video, and then I am trying to save whatever video will be there. The detection will be done, guys. That entire detection will be saved here as a output path. Let me run this file. Okay. So once you run, guys, you will see here the output video will be generated here. The name by the name detected.mp4. Okay. All right, guys. So Chandana has shared the entire link for the feedback, guys. You can take that link and mark your feedback and attendance. Okay. So this is the last code walkthrough, guys, and then we'll try to understand the RNN. So we'll try to understand what is recurrent neural network and try to take a code walkthrough for the same. All right, guys. So this process is happening here. So it is trying to understand the entire object detection. The model is going to save. Okay, 100% completed, and it will generate a file here, guys, by the name detected.mp4. Okay. So I passed one video and it will be able to detect the video and give me the output, guys. Within that video, it will detect the student, it will detect the book, backpacks, the entire mobile book and everything. And this will be live, guys. This will be live. Okay. So let us refresh this one. Okay. So this detected video is generated, guys. So let me download that video and then let me run that video. Okay. So go to the downloads and detected. All right. And let me show you now with the result, guys. See here. Now you can see real-time detection happening, guys. Okay, handbag is getting detected, the person is getting they are walking. Okay, their pot is getting detected, cell phone is getting detected. You can see here. Let me make it back, and you can see here, cell phone is getting detected, guys. Okay, the cell phone is also getting every minute detail is getting detected. Person with the confidence score, every pot here. You can see the pot is here for flower pot, and then there is a one more plant is there, right? And even the person will be walking out of that door, guys. He will also get detected. Okay. So this is awesome, right? Within a 5 to 6 line of a code, guys, you can see here, you are able to detect the entire picture, entire video, entire thing will be getting detected. All right, guys. So this is how you can perform a pre-training, guys, and you can perform an entire model, and you can customize this also. Okay. And guys, if you want to customize this, let's imagine this is done. Okay. But if you want to customize this, that is also code I have given you. So in customization, guys, you just have to create one kind of a things. Let's imagine this way. So what you have to do is for the customization, same model you can take. Now only some settings you have to do. What settings you have to do? Let's try to understand within a 2 minutes, guys, and then I will try to tell you how to customize this entire model for your own class. Okay. So let's imagine, guys, that you want to customize this model. Okay, you want to customize this entire model. So I'm providing you this custom dataset .ivlb here. Okay, so let's try to understand this here. How do you can customize this for your own category data, YOLO NAS model, latest model. So what we have to do is, guys, first we have to create one folder here. Let's try to understand. This is my category folder. So fault detection, what I'm going to do, let's try to understand here. What will be my result? If I try to pass any picture or video, guys, here, and within that picture, if someone person is falling, it will get detected, and it will try to create a round bounding box here, and it will give me a confidence. What is the fault detection confidence? Okay, and why it is important? Like, let me tell you. Okay, so what is going to happen? Let's imagine if you have fitted this camera in the traffic signal. Okay, in the traffic signal camera, and some person making the accident, immediately it will be able to detect, guys. If you fall down after the bike or car or something happens, goes wrong, and it will be able to detect. Like I can show you some picture I have taken from the live web camera where people are falling down on the road. Okay, so you can check this here. All of a sudden, this person got the heart attack, and on the road he has fallen down. Okay, this kind of a detection it will try to perform, guys, and it will directly be able to give a intimation, and then it can call an ambulance also. So that kind of a real use case we are trying to take. See, this is a real-time picture I've taken from the web camera. So what I'm going to do is, guys, I'm trying to create this kind of a notebook here. So for this notebook customization, what I have to do is I have to create first folder for my category. My category is fault detection. Within that, I am creating 3 folders. One is val, test, and train, guys. And here I am passing my images. Okay. Here I am passing my image data here, whatever the images will be there. And I am creating one more folder, which is called as label, guys. So labels means what happens is, let's try to understand. It is trying to give me a coordinate. So what coordinates it will be giving me, whatever image I am passing. Okay. For that image, guys, I am trying to create this kind of a bounding box, and this bounding box height. Okay. The height, width, and XY coordinates will be taken, and that will be stored. Okay. That will be stored in the label column. This is what the data I am passing, guys. Okay. 2 type of data. Original image I will be passing, and along with that, one X and Y coordinates means center point here, X and Y, and the height and width, guys. Height and width of these boxes. So these boxes information I'm passing in the label column here. This label, and this is my original picture. So these things, there are 2 type of information, and for such information, guys, I'm going to create a 3 folder. One is test, and one is train, and one is validation. We can create even 2, more than enough. Train and test. Okay, but for the safety purpose, I've created a 3rd validation folder as well, right? So what information goes here? Let's try to understand once again. See here. So this is simply the coordinates, center coordinates, height and width coordinates, right? This coordinates, and this is the image, respective image. For this image, when you try to draw boxes, and how you can get this information, guys, there are online tools, annotation tools. By using these tools, guys, you can create this information. Okay, so let's imagine you have created this information now. So how can you customize your model? Okay, how can you customize your model? Let's try to understand. So guys, what you have to do is you have to install your torch version, because this is based on the PyTorch, right? So you have to install the PyTorch, guys, and from the PyTorch I am importing this device CUDA. So you can see here I am trying to run this on the NVIDIA GeForce and RTX. This is the GPU name, guys. Okay, I am trying to run this model on the GPU. Okay, okay, Priya, WhatsApp link. Okay, Chandana, can you please provide this Priya call WhatsApp group name so she can join that? Okay. Okay, guys, my colleague will provide you the WhatsApp group, and she'll try to reply to you. Okay? Don't worry. Guys, what I'm trying to do, I'm going to use this GPU. I'm installing my PyTorch. Okay, then what I have to do, I have to create one kind of a trainer, guys, here, because whatever YOLO model I'm going to take for that purpose, I see here this kind of a data sets are available. Out of that, we have taken a Coco data set. There is a Pascal, there is a YOLO Darknet, and YOLO 5. This kind of a data sets is there. So what I have to do is, guys, I have to create this data set and data loader first. So data set you don't have to create, you just have to create a loader. And in the data set, we have to create something called as now, something called as your checkpoint directory. What is this checkpoint directory means? Here there will be a checkpoint directory, CHK directory. In this directory, guys, whatever the train model is there, that train model will be saved here in that directory. And the second path, trainer, this path tries to talk about your this directory, this where you are stored all your images and label, guys. So this kind of a 2 directories you have to create. This is what we're trying to create first. and this will be called as trainers. Then once we create a trainer equal to my first YOLO NAS, I'm just giving a model name. Okay, first YOLO NAS, and I'm passing my checkpoint directory guys. And then I'm trying to create my parameter here. What kind of a parameter I'm passing here? Dataset parameter means where is my test data, where is my train data, where is my label data, what kind of a label test image data set, train image data set, my label data set folder, and what are my classes. Here I have taken only single class, fault detection. If you want a multiple class, you can add here fault detection, rise detection, then some is guys seed detection, run detection, whatever file category you want, you can add it here, guys. Okay. This is the simple thing I am creating here. Directory for the entire path, this fault detection directory. Where is my training data? Where is my validation data? Where is my test data? This directory I am creating, and number of classes, what class I am creating. If you have multiple, you can add it here. Okay. So that's what I am creating as a training data set parameter, guys. And prior to that, I just created one folder out here. Okay. Then guys, what I have to do, let's try to understand. So whatever this path I have created, what is this data I have created, I'm creating one kind of a generator now. So the generator name will be Coco detection YOLO train. So within that same parameter you have to pass, whatever parameter we have generated, same parameter, like where is your image file, where is your label file, and what are your classes. This is what the train data is there, test data is there, and that validation data set. That's what you have created, guys. Then what you have to do is you have to call your model trainer.train data parameters. The train data parameters are from transformer model. Okay. So this is the one line of code you have to run, guys. And from this transformer model, okay. Yeah, I will give this link. I am going to pass this entire Jupyter notebook link. We'll have both the data here. Okay, I will give you guys. Don't worry. So guys, then I'm trying to create this data set parameters, and from this data set parameters, guys, you can check here. So this kind of a different data I have created, like where the person is falling. One person is falling while playing the football. One person is falling on the road. One person is falling. This child is falling on the bed. Then one person has taken from the sports ground. One I have taken from the entire live camera. Okay. So there are different, one person is sitting beside the tree and has fallen down. So different kind of images we have taken, guys, and then that is taken as a train data set. Now, then what you have to do is like same way we have done, like form super gradient library, import the models, and from the models.get YOLO NAS large number of classes equal to this parameter, training parameter we have passed on these classes, and pre-trained with equal to Coke, guys. That's what the model will be there. And then once I take the model, we have to write this kind of a epoch, how many epochs you want to take, what kind of a metrics you want to take, what kind of a optimizer you have to take, what kind of a loss function you have to take. Okay. So that information you have to pass here in the training parameter. Okay. In the last training parameter. So this is simple function, guys. Don't go with this kind of a number of parameter. Don't get confused. Simply it is trying to tell you this information, that how many epochs you want, what kind of a loss function you want, what kind of a optimizer you want, what is the trend test split you want, and what is the metrics to watch means accuracy metrics. Okay. This is the simple information I'm passing here, guys. That's it. Don't get confused. And now you can check that maximum iteration I'm passing here, max epoch equal to 100. Okay. Max epoch 100. And this information once I pass, guys, my entire training is ready now. I'm just simply calling my trainer.train. I'm passing my model information, passing my training parameter information, and my trainer data loader and validation data loader, which we have created here. These are my training parameter. This is my model, guys. Model.get this YOLO NAS, and this is my loaders, these data loaders which we have created. This simple information I'm passing in the end, guys. Okay. Whatever information we have created, that simple information we are passing to trainer.train, and that's it, guys. Your model will be get trained with the 5 line of code, and you can check your best training model also. So there will be path here. There will be one directory created, and within the directory, guys, will get this kind of a file. So best model or latest model. So you can choose the best model weight here. It will be saved by the CKPT_best. Okay, this will be your model file. And once you take that model, you can say trainer.test, take your best model, then load your test data set, and you can perform a detection, guys. So this is what the detection parameters are there, and that's it. So once you pass this kind of a precision will happen, and guys, this is the result you are getting here, right? In the result, you can see this picture we have passed, and it is able to detect the child has fallen down on the ground with the 72% accuracy. All right. So now everyone understood end to end how to customize the model, how to train the model, and how you can train the model, guys. And for your purpose, reference purpose, I'm passing this entire GitHub link, okay, in the chat box, so you can copy paste and keep it for your reference. Okay, guys. I'm sharing with everyone this entire YOLO model. Okay, entire YOLO model. Let us save here. I don't want to give a single link. I will give you an entire link. Okay. This entire YOLO link I will be giving you. So every file is there, custom data set, normal data set, default detection, everything is shared. So this entire data GitHub link I will give you. So from where you can get the entire link. Okay, guys. So I'm sharing with you everyone. Praveen Raj also. I'm sharing this GitHub link with everyone. You can keep this link, guys, with you. And from this link, you can download your models and you can customize them. All right. So I guess, guys, everyone is now comfortable, understood. So what is this entire computer vision model works upon, how they works upon? Any questions, guys? Any doubts before I try to tell you what is the RNN, recurrent neural network? I know 15 minutes are there, so these are more than sufficient. I can tell you how this recurrent neural network works upon, and we can make a small code walkthrough in 5 minutes. Before we proceed, guys, any questions like how to use the pre-trained model, how to freeze the layers, how to use the convolution neural network to create your own image classifier? We have taken all the examples like 10 class classification, 2 binary class classification, how to customize for the video data, how to customize for the image data, right? Everything we have seen here, guys. So any questions, any doubt, any queries before we start our recurrent neural network? Not getting you will get, guys, don't worry, this recording video will get uploaded in the LMS. So Praveen Raj, I guess you have registered for this LMS, right? This LMS link, so you will get all this video, don't worry. You get a material also, all the material, guys, all the artificial neural network code also, everything will be getting uploaded. All right, guys. So apart from that, any other question, guys? And let me share also with you guys the entire link for the feedback and the attendance once again with everyone. Same link which has Chandana has shared. I am sharing the same link, so you can mark your attendance and feedback, guys. Apart from that, guys, any other questions, any other query, doubts? Please let me know before we start our next 10 minutes overview of the recurrent neural network. All right, guys. Yeah, in LMS you will get content. Not able to see the previous workshop. Okay, don't worry, guys. I will tell it to the technical team, and they will rectify everything. Don't worry. I will tell it to the technical team. They will upload it everything. All right, guys. Then I think we can start with the recurrent neural network. We'll try to understand what is the recurrent neural network, and from that we'll try to understand one small code walkthrough also for the recurrent neural network. Okay? So I'm not going into the details, guys, for the text analytics, which we have already seen this. So you guys already know when we try to talk about the NLP session, guys. So NLP is a part of the entire AI, which is also a amalgamation of the machine learning, deep learning, and it is using machine learning technique as well, deep learning technique as well. Means it will be using the y equal to mx plus c, all the statistical algorithm which belongs to the machine learning, and it is also going to use the ANN and RNN, guys, this NLP domain. Okay, so when we try to talk about NLP, NLP is nothing but we try to understand the human-like languages, right? And for NLP, guys, it is broadly classified into these categories. One is natural language understanding. Second is dialogue management and natural language generation. Let's try to understand what is this all about, right? So what are these three domains? Let's try to understand what is this dialogue management, guys. This is the dialogue management. Dialogue management means kind of a chat bot. You can understand the chat bot. Okay, so for the chatbot, guys, these are the frameworks. This is framework created by Google Dialogflow. Okay, Google Dialogflow is a framework using which you can create a chatbot, guys. Chatbot. Okay, so which will be able to give you a question and answer. Question answer. You ask a question, it will be able to reply you in the English like human language, right? From the Amazon, there is Amazon Lex. Then from Microsoft, there is a Louis agent is there, guys. Louis. And from IBM Watson, guys, there is IBM Watson agent. Okay, so this kind of a framework available by using which you can create a dialogue management. It is called as DM, dialogue management. You ask a question, guys, you will get a reply answer as a reply as an answer. That kind of a technology which can create by using this dialogue management, right? No need to explain what is this dialogue management, guys. This is one part of the NLP. Now second part is natural language understanding. Okay, let's try to understand what is this natural language understanding. Guys, natural language understanding means you try to provide one text data here, like one kind of a paragraph. Okay, and I will be able to understand that paragraph, and I will be able to tell you the emotions. Okay, so what are your emotions or sentiments? What are your sentiments? What you are trying to speak here? Okay, sentiment like positive sentiment, negative sentiment, or neutral. Okay, so this kind of analysis. So you pass a text, guys, I'll be able to understand and I'll be able to classify that text. That is called as natural language understanding. Or you pass a one text, guys, I'll be able to give you a summary. So what is the summary of the entire text, right? So this kind of a application, it is called as natural language understanding, guys. All right. And then, guys, natural language generation. Let's try to understand. This is very, very important field. Natural language understanding means natural language generation, guys. Means you provide one text, guys. You provide one text and it will be able to generate a text for you. Or you provide one text, it will be able to generate an image on that. Okay, image. Or you provide a text, guys, it will able to generate a video out of that image. So that kind of a things is called as natural language generation, guys. Natural language generation, all right. So let's try to understand. I think everyone is now clear what are the broader category of NLP, right? So NLP is about natural language understanding. NLP is all about the dialogue management. So this kind of a chatbot creation and then natural language generation, like you are trying to understand this kind of a things, right? You provide a text or predicting the next word in the sentences, right? Or try to classify your email, whether that email is a spam email or non-spam email. Okay, so that kind of a classification, or like you provide a text, it will be able to generate an image out of it. So this kind of an entire application will be called as NLG, natural language generation, guys. All right. So let's try to understand what is this natural language generation. So guys, this NLP, whenever we try to understand, this is also called as conversational AI. Conversational AI, because we try to understand the human-like languages, we are trying to speak with it. Your machines are able to understand the entire task of human languages, and then it will be able to give you a reply, right? So this is what is happening. This is the simple example I've given you guys, because the text data is like, it is not that simple. It is a very the text data is very superficial, but the language is very complex, just like the Asperger, right? There are million meanings. Like if you try to understand the sarcasm, if you try to understand the emotions, and this is very, very difficult task, right? So that is why they are talking about this, guys. We'll not try to focus out here. So let's try. This is the entire like kind of a framework, guys. If you want to become an NLP expert, you have to start with the neural network. Then you have to understand this entire backward propagation, forward propagation. Then you have to understand the text generation, which we already covered here, guys. And then we have to understand something called as recurrent neural network. Then from the recurrent neural network, there is a advanced model like LSTM, GRU. Then there is a word embedding layer is there. And then from there, guys, we can understand transformer and BERT. This kind of application. These are the highest level of application. Yeah, this PPT will be uploaded, guys, in LMS Praveen Raj. Okay, don't worry, sir. This will be available. So guys, this is the entire roadmap how it look like, where to start and where to end. And then once you are able to understand this kind of a thing, guys, you'll become an entire NLP expert, all right? So let's try to understand, guys, now recurrent neural network. So what do you mean by recurrent neural network and how the recurrent neural network works upon? Okay. Let me share with you guys. Okay. Let me share with you this entire recurrent neural network. Just give me one moment. Then we can understand this NLP part. Just a moment, guys. Let me stop sharing and let me share this presentation. A simple presentation there. In 5 minutes, we can understand this one and we can go for the code walkthrough as well. Just a minute, guys. I'm sharing my entire presentation with you guys. Just 1 minute. Yeah, okay. So let me share this thing. Okay, so I guys, now you guys can see my presentation and let's try to understand what is this recurrent neural network is all about, guys. And then we'll try to make a small code walkthrough using this recurrent neural network, like fake news detection, that kind of a project we'll try to understand, guys. So guys, let's try to understand what is happening actually. So when I try to talk about the recurrent neural network, guys, the recurrent neural network, why they are coming into the picture and what is the need actually, and let's try to understand this one. Guys, what happens is like how the information flow happens is like we try to obtain the data, then we try to process the data, we try to understand that data, and then we try to create a sequential kind of action, right, out of it. Let's imagine that if you're trying to talk about some person, so at that time what is happening is you try to understand the person, then you try to start greeting, and then we'll try to talk about one topic, yes, and based on that topic we'll try to continue our discussion, right? Means what is happening is when you try to talk to this person, that text data will be generated, some words will be generated. On each word will require some prior knowledge, right? Prior knowledge means what is happening is now you started here and you started to greet person. You said hi, then you will be saying hello, then what is your name? And then we'll try to talk about certain topic. Let's imagine I'm trying to talk about the topic that my name is Vikas. Hello, I am Vikas. I am Vikas and I am from Pune. I am from Pune. This is what I'm writing, right? And I can speak Marathi, I can speak Hindi, I can speak English, right? This is what I'm saying. Means what I'm trying to do. So when I'm trying to talk this sentence or trying to understand this sentence, guys. So this I refers to what? Vikas, right? I am trying to refer to Vikas, right? This is what I'm happening. Means what I'm trying to say is when we try to understand the human thoughts and entire things, means when I'm trying to talk about this I belongs to Vikas, right? So this could be possible. Whether this I belongs talking about the Pune place, object, or this kind of a things, this kind of a connection is required, guys. If you want to understand, if you want to analyze the entire text, means whenever I say I am because I am from Pune and I can speak Hindi, English, Marathi. So this kind of a things, this can be a place, this can be object, this can be person, right? So as a human being, it is very easy for you to understand. But for the recurrent neural network, for the machines, guys, they need to have some kind of a recurrency. Means what is happening? I need to have some kind of a connection out here. So what this I talks about, whether this I talks about Vikas, whether I talks about Pune object, or whether it talks about the languages, right? So that kind of a recurrency is there, guys. That recurrency, because of this recurrency, they have created this kind of a recurrent neural network. And let's try to understand how the recurrent neural network works upon. Because what was happening initially that in text analytics, guys, I'm passing this kind of a data. Then what I was trying to do, I was trying to perform a tokenization. This tokenization I was doing. Tokenization means simply, guys, I'm trying to break this entire paragraph into the words or sentences. Then from there, I'm trying to remove my stop words, right? I'm trying to remove my stop words. Stop words means this kind of words. From, every, right? Don't, have, this kind of words I'm trying to remove. And then I'm trying to remove these punctuation marks, other things. Then I'm trying to perform a stemming means if I'm saying thinking, I will try to bring that sentence to a think. Though I'm trying to perform a stemming, all this kind of operation I'll try to do, guys. Then I try to convert that word to a vector. So after that, let's imagine here. So I'm trying to take this sentence and I'm trying to analyze the text analytics here. This is what we have learned in our earlier series, right? How to perform the text analytics using this kind of a NLTK library, right? NLTK library, what I'm trying to do, I'm trying to take these sentences, trying to break them into the words first. That is called as tokenization. First step I'll be doing is tokenization. I'm trying to tokenize the data. Then second step I'm trying to do is I'm trying to remove my stop words, right? I'm trying to remove my stop words. So here I'll try to remove my stop words. Stop words are like this kind of words. Have, don't, right? I'm removing them. Don't, there, from, right? So every, I'm trying to remove you, as, you, this, right? This kind of a words, each, on, your, right? Prior will be there. So guys, this I have removed. Okay. Then what I'm trying to do, I'm trying to perform something called as stemming or lemmatization. Stemming and lemmatization, guys. I try to give you a practical example. Lemmatization is try to bring the word to its base format, right? Bring the word to its base format. So means I'm trying to write thinking. I try to make it think, right? So this way, guys, I'm trying to bring it to the prior basic format. And then when I'm trying to bring the basic format, guys, then I'm trying to convert in the fourth step the text to word. This text to number, right? Text to vector actually. Text to number means vector means what will happen in the end, guys. I try to create this kind of a table where I'll write like first word will be my human, remaining word human. Then I'll try to write like thought, I'll write, guys, for thoughts. Then one more human is already covered. Then think, there will be word kind of a think. And then, guys, I'm trying to write is a scratch. Then the second, and then I'll write I'll understand. And this kind of a vector will be created, right? And there will be a number assigned to it, guys. So we have understood for that reason. Let me rub these things. My final TF IDF, right? I use term frequency and IDF frequency, by using which I have created this kind of a vector here, correct? So this table is created, guys. This table contains the words like this one, human, and then the knowledge, KNWLDG. I'll write knowledge. Then the sentence, SENT, sentence. Then I'll write this thought, and then I'll write a persistence as PT. And then, guys, I'll try to write scratch, ST, right? So this kind of a word will be created, and then we will have a create a numbers here, term frequency and IDF frequency, right? So this is 0.25. So 0.25, I'm writing imaginary score, guys. So 0.1, 0.1, and there will be 1 point some score will be generated. In the end, guys, I'll get a combined score, TF IDF score. So this score will be generated like this one, 0.7, let's say 0.8, 0.9, 0.2, and point so on. And guys, once I am able to generate this, I used to build my machine learning model. Now, guys, try to understand what is the problem out here. So when you try to understand, guys, every word is separate here. Every word is separate. Is there any connection between the words I am creating? Am I creating the entire connection between the words, right? I'm not creating any connection, guys, at that time, right? So that is the problem here. That is why the recurrent neural network, RNN, comes into the picture. Because we try to understand, when I'm trying to understand the entire language, and let's imagine you want to convert this language into English to German, right? And English to German. So what I have to understand is, when I'm trying to talk about human thoughts have persistent, human don't understand there. So this there talks about the human, right? That kind of a connection is not there in TF-IDF. When you try to perform a text identification, text analytics, right? So for that purpose, the RNN is created where they are creating a connection to this entire sentences. And when we are creating a chain of the thoughts, guys, chain of the thoughts, we can understand that, we can convert them into the entire actual meaning, and then we try to understand the meaning. That is what the recurrent neural networks are doing, guys. So let's try to understand what is my recurrent neural network and how it look like, okay? And what is the use cases? Guys, very popular use cases, like we can create a time series related data like stock price prediction, sales prediction, or you can take the raw center data and you can understand, or handwritten label reading, right? So whatever you are writing, then text data you are taking and try to perform it as a sentiment analysis, emotion analysis, or you are trying to pass one text data, guys, it will be able to generate a video or image out of that data. That kind of application you can create using the RNN, guys. Okay. So I have written here activity recognition, machine translation means English to French, German. Like you can create a question answer chat box, question answer, right? Or you can create a speech recognition, like you give a voice and it will be able to convert into text, guys. You write something, it will be able to generate a text on it, or you can perform a text on that basis of it. It will be able to generate an entire paragraph or explanation, right? So that kind of application are created using the RNN, guys. All right. So very, very quickly in 2 minutes, let's try to understand what is this RNN. This RNN, guys, this has this kind of architecture. Let's try to understand. I know it's a time, so I will not take more than 5 to 7 minutes, guys. So we'll try to understand this RNN and we'll try to make one code walkthrough here. Let's wait for 5 minutes, guys. You can bear for 5 minutes and we'll try to understand this RNN, guys. This is what the RNN cell look like, okay? So this is what is called as recurrent neural network. This is what is happening here. Let's try to understand. This is the folded version, guys. This is something called as folded version of recurrent neural network. This will be a neuron. Here we'll be passing the data X input. Then it will get multiplied by here weights, guys. Then it will be able to generate output over here. So that output, guys, next time will be again given here for the processing. Then next time I will try to pass one more input. So this way, guys, what I'm trying to do is I'm going to give a new input every time. Let me rub the things and let me write it in proper way. Actually, what I'm trying to do is, so let's imagine here I'm passing X1 input. So that will get multiplied by weight, guys, and here with the processing happen. That is two-step process. Remember our step 1 and step 2 process will happen, guys. And then after that step 1, step 2 process, this output 1 will be created. This is what will happen first time. The same cell is there, but it is a multiple iteration. In the second time, guys, it will try to take the next input. Now the same cell is there. Now we are not changing the cell. We are not changing the layer, guys. But same time, we are passing the next input here. It will be accepted here, multiplied by the weight. But this output 1, O1 will also get added, guys, here. And it will try to generate output 2. So next time, it will try to pass X3 here. At that time, X3 will try to process here, but it will try to take O2 here also as the input. And this way, guys, in the end, we'll try to create a prediction. This is what is called as recurrent neural network. That's why you can see here this kind of a cycle is created here. You pass the input, it will generate the output. That output is also given at the second iteration for the next processing. Okay. So let me expand this. So I told you this is a folded version. So when you try to expand, guys, this is what the actual recurrent neural network will look like. Okay. So this single cell actually, guys, what will happen is, let's take the example of machine level translation. Means you are trying to write in English, guys, it will try to convert into the German. So I am writing I am Vikas. Okay. I am Vikas. So this is what the input I am passing, and it will try to generate in the German Ich bin Vikas. Okay, this is what the German is translation. So what will happen, guys? Same neuron is there, but this will happen multiple times. So I will be taken here, guys. It will try to perform and it will try to generate one output over here. So that O1 will be given next time as an input, plus this second word will be taken M. So I and M both are combinedly processed and it will generate a O2 here. This O2 is also given here third time. It will try to take the Vikas and Vikas will be taken, guys. It will generate a output here. Okay, this way it is trying to create a chain of the reaction and then it will try to perform. And this is how the entire enrollment happens, guys. Yes, guys. One single neuron architecture is there, and this single neuron, means there will be actually multiple neurons will be there in the architecture. Okay, so let's try to understand this one. So what happens? This kind of a neurons we can arrange here, and actual neurons operation. I can tell you this one. See here. So this one neuron could be there, or there could be multiple neurons possible. Okay. So this input one will be given, guys, and it will get multiplied by the output, and it will try to go through this one. It will generate output. That output will be again given. Okay. This will happen multiple times, guys. Same layer is there, but this is happening. See here, same layer, but multiple iterations are happening. Multiple. Rather than taking multiple neurons, they are trying to perform multiple operation, and that's how you get output here, guys. So what output you get? This is very good example. This is a forward propagation. You pass one input, get multiplied by this W weight, and this will generate a output one here. That output one will be given along with the next time. Thus X2 is given, get multiplied by W2, and it will try to take O1 also. So that's why you can see here W into X plus O is taken. O means previous output. This previous output is also taken as the input, then combine it, perform the operation. Everywhere it is trying to perform the same thing, guys, and then it will try to give you output. So this is what happening. The single neuron is there. This single neuron could be there, could be multiple neurons could be there, but the layer will be only one. This one layer will be there, but the iteration will be multiple, guys. This is the first iteration. This is the second iteration. This is the third iteration. This is the fourth iteration. Now let's imagine what will happen if you try to pass the same information, because there will be million words. So for million words, you will require a million neurons. But because of this iteration, recurrency, guys, we will be able to accommodate all 1 million words into this kind of a single kind of a neuron layers, right? One layers. Within the one layer, we can accommodate 1 million words, and that is the beauty of recurrent neural network. That is why it is used, preferred over the artificial neural network. So everyone clear what is this happening? In the same way, guys, it will try to perform a forward propagation. In back propagation, it will try to update both the weights. This weight 1 and this weight 1, weight 1, 2. Okay. So let me show you the same thing. Every architecture, everything will be same, guys. Apart from only one thing that here we try to stack multiple things, but here what is happening is same cell is getting iterations multiple times. First iteration, second iteration, third iteration, fourth iteration, then it is going to give you output, guys. So same operation like forward propagation, backward propagation, all the operation like in an artificial neural network will be performed, guys, and same weight updation formula is there. But here only two weights are getting updated. One weight initially when we pass here, and the next weight will be with the output associated W dash. So two weights will get updated here by the same formula, derivative of loss with respect to weight, guys. Everything will be same. All right, guys. So this is what the beauty of the recurrent neural network, and this is how the entire forward propagation, back propagation will happen, guys. It will have a same problem like vanishing gradient problem, all the problem, and this way it will try to perform. Okay. So guys, let's make a small code walkthrough here. Okay. So let's make a small code walkthrough for the recurrent neural network. I try to showcase you how to perform this kind of a entire fake news detection, and that will be a like good example. Okay. And that's it. We'll try to end up our session. Just give me one moment, guys. I will try to share this thing with you. Just one moment, guys. In 2 minutes, we'll be able to finish the code walkthrough. How to create a fake news detection using recurrent neural network, guys. Just I am opening my Jupyter notebook. Very simple explanation is there, guys. 5 to 10 lines of code and we are done. All right, guys. So everyone can see my Jupyter notebook now. So what we're going to do is, guys, we're going to create a one fake news detector here. So I'm taking data, fake news data here. So I'm reading that data as here, data frame, guys. You can see the entire data here. So I have read the data by using pt.read.csv. And this is the path, guys, I am given here, the path for how from where I've taken this fake news data. So if you try to look at this data, guys, what is the data? First column is ID, number, then title, guys, then author, and what is the actual news. Okay, actual news. This is the news. This is the author, this is the title, okay, and this is the ID number. This is how my data looks like, all right. So this is the data I have read, and this is calling as data frame now, all right. And this is my last target column, Y, and all this will be Y. Whether this is news is fake means 1, whether this news is genuine, 0, okay. So this kind of a data I have taken, guys. Then what I am trying to do is, if you try to check the shape, guys, I have taken a 20,800 news, okay. 20,800 news taken, and this is a 5 column. Now, guys, looking at the column, can anyone tell me what are the not important columns here? Which are my unimportant columns here, which I can remove here? So this entire columns out here, okay, which I can remove, okay. Author, okay, possible. Yes, I can remove author also. But guys, let's try to understand. So author ID, Praveen Raj correct, Mohammed correct. So I can remove actually ID column. I'll try to keep this author column. I'll try to go with the author and try to see, and later on at the second iteration I can remove this author as well. Okay. So guys, this is my target column here, label. So this is fake or not fake. This one means fake. Okay, 0 means not fake. Okay. And then I will try to keep this title, author, and text. Actually, 3 columns I'll try to keep. I'll call them X, and this I will call them Y, guys. Okay. And this ID column, I'm going to remove this. This is what I'll try to do. Then I'll try to remove the duplicates. I'll try to remove the NA values. I'll try to remove the 0 values, guys. And then I will try to build my own recurrent neural network here. Okay. So this is what I'm going to do. See here, I am taken 20,000 plus records. Then, guys, I'm trying to check whether there is any null values are there. So if null values are there, I'll try to drop this null value, df.drop null value removed. Then I will try to remove this ID column as well. And then I'll try to check the shape of the data, how the shape of the data looks like. Okay. So after that, guys, what I'm trying to do is I'm going to import my TensorFlow here as TF, because, and from TensorFlow, I'm using the Keras model, guys. This sequential, you guys already know, sequential model. Then I'm trying to use something called as, guys, my LSTM model. Instead of LSTM, you can write RNN model also. Okay. RNN layers, you are using RNN. Then you are creating one layer, guys, embedding layer here. So try to understand what is this embedding layer. This embedding layer, guys, it will try to convert me this entire sentence like this one. Okay, this Hillary Clinton, big woman. Okay, so it will try to convert them into this kind of a numbers here actually. So this is what the embedding layer I'm actually trying to obtain here. This is embedding layer, guys, is the advanced technique actually. So it is called as feature embedding, and it will be able to convert the entire text into the kind of a words or kind of a vectors. Okay. So this is what I am importing, guys, here. Instead of LSTM, you can call RNN. Okay, RNN. You can call RNN. Then, guys, what I have to do is I have to tell what is my vocab size. Vocab size means when you try to convert my entire words into this kind of a vector, right? So that vector size should be decided, right? From 1 to how much? So I'm taken 5,000. 1 to 5,000. 5,000 means whatever the text data I will be providing. For every text data, I'll try to create one kind of a numbering system here. So means let's take this example, Hillary. So if this Hillary is there, Hillary will be stored at this kind of a vector between size of 1 to 5,000. And let's imagine this Hillary is stored at location 200. So at the 200 location, it will be 1, guys. And everywhere up to 5,000, it will be 0. So this kind of a encoding we are going to create here, guys. And by using this kind of a encoding, we are trying to convert that into the numbers, guys. All right. And one more thing I'm trying to do is fixed size equal to 20 means what? So let's try to understand what is this fixed size. Okay. So Flynn, Hillary Clinton, big woman in the campus. This is what my entire sentence is there, right? Actually, if you try to read the sentences, how many words are there? 1, 2, 3, 4, 5, 6, 7, 8, guys. The 8 words are there actually. So some sentence will have 8 words, some will have 10 words, some will have 20 words. To bring them on the same scale, I'm trying to call as a fixed words 20. And then when I say fixed word 20 is what is happening is, guys, this padding sequence I'm calling same like we have added padding layer. What will happen? It will be a pre-padding or post-padding. Means after the sentence or before the sentence, I'll add 0, guys. So you can see here, this is a post-padding. So after the sentence, this sentence completion, I'm adding 0, 0. So this is called as pre-padding. And if it's a post-padding, pre-padding means before sentence, I will be adding zeros here. And by this way, I'm trying to bring them to the same scale of 20, guys. Okay. So this is called as now padding. So vocab size I created my layers, guys. And then I'm calling this here message X equal to means this kind of a thing. And this I'm trying to convert them using one-hot encoding. I'll try to create a one-hot encoding. So I'm calling my entire libraries here. So from this library, I'm calling my stop words because, guys, every processing will be same. We'll try to tokenize the word. We'll try to remove the stop words. We'll try to remove the the special character. We try to split them and we'll try to join them. And this way, entire text cleaning will be done first. We can see here entire stop word removation, punctuation marks removation, converting to the lowercase, everything will be done, guys. And then after that, I'm trying to convert them by using this kind of a one hot encoding. So this Flynn, Hillary Clinton, big woman, by using one hot encoding, I'm passing these two words and this vocab size, and then it will try to convert this like this way, a number system. Okay. So this entire sentence here, it is getting converted to this kind of a number system by using one hot function, one hot encoding, by passing your words, means this words, and your vocab size 5000, which you have created. Okay. So this way, guys, we have created entire one on encoding, and you can check corpus one equal to this sentence, and same you can see here. So this kind of a sentence is created, or you can use an embedding representation. Like I told you, there is an embedding layer. By using embedding layer also, you can create to convert that sentences to this kind of a numbers, guys. Okay. So once I create, guys, then I have to call my model. How to build this model? Same way, guys. First you call model equal to sequential. Then I am trying to write here feature representation means what? Let's try to understand within 1 minute. Feature representation means, let's imagine you have created here 5000 words, right? 5000 vocab. So that 5000 words, guys, will be get converted into some kind of a features. So feature could be like this one. So if you try to take the feature like this way, all the words will be there, and you try to take the feature like human, royal, right? So woman or other categories. So whatever word is there, let's say there is a word he, there is another word like man. Okay. So whether that man belongs to human category, yes or no, that kind of a encoding will be created. Whether he word belong to a royal family, yes, it could be royal family. Then cat, woman, okay, and these categories will be there. And this kind of a matrix they will try to create. And by creating this kind of a matrix, that which word belongs to which category, okay. So this 5000 will be created less, and it will be created to the dimension of 40. So this 40 dimension, by taking this kind of a 40 features and converting this word into this kind of a matrix, they will try to reduce this size from 5000 to 40, guys. Okay. So simple, this kind of a things they will be doing. That is called as word vector representation, feature embedding. Okay. Then this could be one more possible way how you can reduce your dimension. So you are calling your model dot sequential, model equal to sequential. Then, guys, simply just like we add our layers, right? We are adding our layers here. Model dot add embedding layer. This is my embedding layer. My embedding layer, I'm writing my vocab size, that how much vocab size, that was 5000, right? Vocab size. What was my fixed length size? We try to make it fixed to the 20, right? This is what the parameter I am passing. Then I am passing my vocab factor, like feature vector. That's it. Only 3 inputs I have to pass, and I have to call my embedding layer, guys. Okay. So once I call my embedding layer, guys, whatever the entire vocab was there, the 5000 vocab size will get reduced to this kind of a feature vectors. Feature vectors are 40, means 5000 to 40 conversion. This is what I am writing here. Input size I am writing 20, and vocab size I am writing 5000. Okay, this is what the simple one layer I am calling, guys. Then I'm calling my model, model dot add. You can call LSTM model also, or you can call your RNN model. So I am calling my RNN model here. Okay. So I am calling my RNN model dot RNN, and then within that you have to write how many neurons you want. I'm saying add 100 neurons. Then this is my last layer. Okay, model dot add dense layer means output layer here. So this is my RNN layer. I am taking 100 neuron here, and out of 100 I am taking in output layer only 1 neuron, because my classification is binary class, whether this is a fake news or not a fake news. All right. Then I'm saying model dot compile binary loss function optimizer Adam matrix accuracy and model dot summary. That's it. Only 5 lines of code, guys. Only here what we have done is, so we have added our dense layer here. Okay, model dot dense, plus we have added our RNN layer, or you can add your LSTM layer. LSTM is a advanced model of RNN, guys. Okay, so you can add any model, and second model is for your RNN and your activation function. Then your model dot compile same code, and then model dot summary, guys. So once you create this model dot summary, your model is ready. Okay, so once your model is ready, guys, you can train your model. So you can pass your train test split data. So I'm passing whatever the data frame was there, initial this data frame, right? So it has a 20,000 plus record, right? This to 18,000 plus record after cleaning. So that record I'm trying to split that data using train test split, and I'm taking 30% data in the training, remaining in the testing, and then I'm passing to my model dot fit xtrain ytrain validation data set. Number of epochs 10 and batch size 64 days. So 10 epochs I am running. Then, guys, once you run this model, so obviously you will have a something called as this kind of one more addition I am shown you with the dropout. Otherwise the code is same, guys. And once you say that, then you can choose model dot predict, pass your test data, and when I'm passing my test data, guys, you can directly get the confusion matrix, and you can get an accuracy score also, right? Y test and actual prediction. So 90% accuracy, guys. And this is our classification matrix. What is my recall? What is my precision? So this way, guys, you can create an entire your fake news detector using the recurrent neural network. And look at the accuracy, guys. Very high accuracy you are getting here, right? So very simple model. One model, this don't get confused. This is the simple model. Embedding layer, sequential model, adding your RNN or LSTM model layer, and then your dense layer, last layer, and then your compile model dot compile, your loss function optimizer, and your summary. And then after summary, pass the 10 trace split data here, and this model dot fit. That's it. And pass number of epochs and batch size. And that's it, guys. And this is one more method, how the same code, but with the dropout layer, for the dropout layer. And then you can say directly. So once the training is done, guys, you can say model dot predict, and you can calculate your accuracy score here, actual value, predicted value, and look at the accuracy code, and you can print your classification metrics as well. That's it, guys. So this way you can create an entire recurrent neural network, and you can create an entire fake news detection. All right, guys, and if you want this entire code, okay, I can share this entire code as well in the chat box. This fake news detection with everyone for your friends. The same code will be there, guys, in the LMS as well, right? In the LMS also, this code is present, guys. You can take it from there as well. So let me go and share with you. Yeah, guys, I have shared the fake news detection Jupyter notebook as well with you guys, and I think that's it from my side now. So we have covered entire computer vision, we compared the recurrent neural network, and even a code walkthrough for fake news detection. So guys, that's it from my side. I think we have already taken 15 minutes late, but it was worthwhile, I guess. So we'll try to rest our session, guys, today. Please go ahead and ask me if you have any questions, any doubts, and we'll try to end our series, guys, by then. And I think you guys have enjoyed the entire session. So please don't forget to tell me your feedbacks. So how did you find this entire session? Recurrent neural network, object detection, image classification, CNN, ANN, entire thing we have taken in the detail, guys. I know recurrent neural network, we have taken only glimpse, but I guess it is worthwhile to see this kind of things. And we have covered all the type of project, guys, with transfer learning model, latest model for YOLO and everything. So hope you guys have enjoyed today's session as well. I know it is late, 15 minutes, but it is worthwhile to spend this kind of things, guys. So I request everyone, please go ahead and ask if you have any doubts, any questions. Chandana has shared once again the entire attendance link and feedback link, guys. I will share with you also. I've shared both the model link and Jupyter Notebook and the entire GitHub link also for your reference. You can keep it for your reference, and all the lectures and video will be available in the LMS, guys. All right. So that's it from my side, guys. I hope you enjoyed the session. Please let me know if you have any questions, any doubts, and then you can directly I think Chandana, we can give them the access. They can unmute themselves and they can ask.
Yeah.
Tell them their feedback.
Yeah, I gave the access. Whoever all want to talk, please
Yeah,
give
Dr.
your
Fatima, thank
feedback.
you very much. Aruna, ma'am, thank you. Chandana, can you please tell me if they can unmute themselves?
Yeah, I gave access. You
Okay,
can
guys.
speak,
So
guys.
I
You can
think
give
how
feedback.
long the LMS access is possible? I think it is for lifetime, sir.
Yeah.
So guys, you can, I think, unmute yourself. If you want to ask any question, please go ahead and unmute yourself. You can give me feedback. You can express yourself and you can tell me also.
Yes, sir. Hello.
This is Dr. Fatima. I hope I'm audible.
Yeah, madam. You're audible.
Yes, ma'am. Actually, this 5 days of FDP is really informative as
Just a
well
moment,
as
guys. Okay,
interesting.
okay, sorry.
Interesting for me as well as again the same resource person. When they are handling the 5 days, there is continuity. We are able to see the continuity also, because if every person again dealing with a different I have attended the workshops where we have 5 different persons or 5 resource persons for 5 different days. So the continuity will not be there, but this session as if we have learned in the entire subject, like that it was. So really it was very interesting. And we would like to have some more hands-on session also in this same
Okay.
topic with Vikas sir.
Yeah, okay, Fatima, ma'am. Thank you very much for your kind words. So really motivating for me to understand this feedback. Okay, guys. Thank you very much, ma'am. So please, guys, go ahead, unmute yourself. You can tell me if you have any query, any question, you can tell me this thing. Everyone has the access, guys. You can unmute yourself and go ahead, please speak. Okay. Who want to go next? Please, I request everyone. Yeah,
Hello.
yeah, Praveen Raj, sir. Please go ahead.
Sir, actually, I think again I'm repeating that, but in the previous workshop also, which we attended of yours, artificial intelligence and current this one also, we are not getting the content, recorded content what you delivered on the day of workshop, right? So those
Okay.
things are not getting uploaded in the LMS part. If I'm not wrong, the LMS link is learning dot onlinelearning.xlr.com. Is that is the SML LMS link that we are opening? Is
Yes,
that
sir.
correct?
For this program, we didn't upload any notes. So by today EOD, I'll upload all the notes. Okay, you can take from there.
Actually, we wanted actually the recorded content, madam. To be
Yeah,
frank,
recording
so
sessions already there. So you have to take from the LMS actually. Drop an email to edl@xlo.com, sir. You can get that recordings. Okay.
And can
okay,
you
okay.
share that LMS link, ma'am?
Sorry, ma'am, I didn't get you.
They're asking to share the LMS link here, actually.
Yeah, I'll share that.
Please share that email ID as well, so where they can write the email if they are facing any technical difficulty then, and they can get the recordings from them. Guys, Chandana will be sharing both the links and the email ID as well. So you can write it to this email ID and you can log into this link and you can get all your recordings and material everything. All right. Guys, who want to say next, please go ahead then. Please let me know if you want to say anything, any feedbacks, any queries.
I sent the registration link as well. Who are not registered, please register that LMS.
Yeah, okay. Thank you, Chandana. So guys, please refer to this chat box and edl@xlr.com. So you can write it this email if you have any queries, any concerns. So you get access related issue, any technical related issue, any recording and coding related issue, it will be solved and you get a entire things on stuff for your reference. Okay. And the registration link is there. If you are not registered, please register on this link. So you'll get access to the LMS. Yeah, guys, please, I encourage everyone to go ahead. If you have any questions, any doubts, please go ahead and ask, unmute yourself, and please let me know. You can give your feedback as well, like Fatima ma'am gave, if you want.
Because sir, it's
Yeah.
very informative and very well you teach. Actually, we understand all kind of concept and from the basic to advanced, and also you explain in well, also in code wise. So it's good to understand every basic concept. Thanks for sir giving kind of the session, informative sessions to us.
Okay. Thank you, Santosh. Thank
Yeah.
you. Thank you for your kind words. I hope you will also enjoy these sessions in
Yeah.
upcoming sessions. Mm.
Yes, yes.
Yeah, Sanam Kazi ma'am, thank you. Thanks for your words. Yeah, guys, please go ahead, unmute yourself if you want to speak, and we'll try to keep it live for 2 more minutes. And otherwise, we'll try to end up our session then. So last 2 minutes, guys, please go ahead, ask any queries, any concerns. If you want to give any feedback, please go ahead, unmute yourself. You can go ahead and speak. Yeah, Shri, please go ahead. Ma'am, we are not able to hear you. Please go ahead. Voice is not clear. Ma'am. Anyone else want to go ahead in that time? Please go ahead. If anyone want to say anything else, you can unmute yourself. All of you have got access to unmute yourself. You can directly start speaking in the webinar. You can also write me in chat box, guys, if you have any concern or queries.
Can I have one question?
Yeah, ma'am. Fatima, ma'am. Close to you.
When to use CNN, when to use RNN? Is there anything like that?
Yeah. When we trying to use the image data and the video data, and for the purpose like we are trying to perform a tracking, object segmentation, or you're trying to perform a classification, or you would want to track any person in real time, at that time we'll use a CNN. And let's imagine if you want to create this kind of use cases like emotion analysis, sentiment analysis, or you want to write a text and out of that text you want to generate a text. Or a simple, take one example, like you got one email and you don't have a time to read the email. So you can write one RNN code. That RNN code will try to convert the text to speech, and it will try to read an email for you. And you can give them the speech direction that please reply to this mail in so and so way. So it will be able to write an email. So you are generating text means you are doing speech to text and text to speech back again. So that kind of advanced sequential data where you are trying to generate a video, you are trying to generate audio, you are trying to generate the text, at that time you'll use a recurrent neural network. But when you are trying to perform a simple task like classification, object detection, object segmentation, pose estimation, that time you'll use a convolution neural network. All right, I hope I answered your question.
Yes, thank you. I have one more question. What about the learning rate in the in CNN? We have the learning rate, right? So how we can fix up the learning rate? So what is the minimum thing what we are supposed to fix the learning rate? Or what is the maximum limit we have?
So learning rate always starts with some with very less value actually. So 0.10 or 0.001 like that way. But actually you have something called as one Keras tuner is there. So tuner is nothing but kind of a hyperparameter tuning. So what we have to do is we have to provide the learning rate and their respective values, multiple values, and it will try to build a model with different values, and you can check the accuracy. So which one gives you best accuracy, that kind of a learning rate you can use. So that kind of experimentation are done in real time actually.
Okay. So what is that? Keras tuner.
Keras tuner. It is called as Keras tuner. So if possible in upcoming sessions, I will try to include that kind of a things as well.
Okay. Thank you so much.
Yeah, thank you. Sanam, you want to ask anything? Sanam sir, man.
Yes, sir. Yeah, I have a question. I read one research paper where the CNN models were implemented. It was not sequential, it was parallel. And then they tried to merge the output of the three into the next block. So, sir, that can be done by writing special code in research, or is there any library like here we had sequential? So, we added sequentially the layers. But is there any other library where we can merge this parallelly, like there were three blocks and then all the three had different filters and then they generated an output? So is there any library for that?
Yeah, I think we have a library for that by using the PyTorch or by TensorFlow also. You can create, but that creation will be like not from the Keras actually part. Let's try to understand. They will try to create one kind of a class actually. Within that class, like class object kind of a thing, and within that class, they will try to create this kind of a blocks. Different blocks will work as a different model, and in the end, they will try to combine it as a class objects model. So that is possible. If you want, you can check the PyTorch site or TensorFlow site. You'll find that kind of implementation out there, how they are combined different models together and they club the entire thing. So it is possible, but it is very advanced technique actually. It is called as ensembling. So bagging kind of a technique is there. So this is usually not used by the people who are like in the normal industry. They're like people users who are in the research and all. They try to use that kind of advanced level technologies. Because in real
sir,
time,
thank you.
in real time you'll
And
not
so
get.
thank you for all clearing all the session doubts. It was really good interactive session.
Yeah, thank you. Thank you for participating. All right, guys. Anyone else want to ask anything, any queries, any questions, any feedback, guys? So before we close the session, finally.
Sir, next workshop, take some very little number of topics and explain more, sir.
Yeah, actually, I can understand. So this was
Here we are
actually too
taking
heavy.
very large number of topics and explaining very
So
few within 2 hours.
yeah. Actually, guys, this demand comes from your side only. So you are the one who have to decide actually. So you guys have to give me agenda, then we can come up with the things. Okay.
Because see, we are covering a lot of topics in just 2 hours. So we want like let's take only
Yeah. Okay.
ML itself in 1 day, 2 days, or 5
Okay.
days itself.
Okay.
Like that.
I can understand, sir. Your concern is very genuine. So yeah, we'll try to plan accordingly. You guys can come up with this kind of a suggestion. We are open for all kind of a suggestion. Okay.
Yeah, I
No
think
problem.
technical team can note down that suggestion. I think.
Yeah, definitely. You can write it to this email ID also, edl@xlr.com, and you can write your suggestion. They can plan the next session accordingly.
Okay,
So
sir.
we'll rather than keeping it in 5 days, we'll try to extend it like 7 or 8 days. So I think we'll get a much time at that time.
Sir, but also it should be like one topic. If it is on 1 day, like with hands-on and all those things, no, that would really valuable.
Yeah,
Yeah.
sir. I can understand. Yeah, I know. Like recurrent neural network also requires like 3, 4 lectures more for hands-on. I can understand. Thank you for your suggestion, sir. We'll try to accommodate that in upcoming lectures.
Yes, sir,
Session.
thank you.
Thank you. Anything else, guys? Anyone else want to say anything before we wind up our session? Pramod, sir, thank you. Thank you for your word. Anyone else want to say anything? Any suggestions, any ideas, anything, any queries? Yeah, guys, if no, then we can wind up our session. Please let me know.
Okay, Vikas, we'll wind up the session.
Yeah, okay then. Thank you very much,
Yeah.
guys. So thank you very
Thank you
much.
so much, Vikas, for the wonderful sessions and the informative topics.
Yeah, thank you, Chandana.
We'll meet on a next program.
Yeah, I also want to thank you, everyone, every participants for such a engaging participation and such a nice and exciting engagement. So thank you once again, and see you guys in the next session. All right. Thank you,
Okay.
Chandana. Bye.
Yeah, thank you. Thank you so much, guys. And if you have any queries, please drop an email to edl@xlr.com. So my team will connect with you, okay? Like regarding certificate also. Certificate will be provided within 7 working days to your working email IDs. I sent that email ID in the chat box. Please take it from there. Okay, then. We'll wind up the session for today, and next program will meet. Up to then, take care. Bye bye.
Yeah, thank you once again, everyone. Bye.